classify and detect the objects within an image with bounding boxes bounding the objects. This means that we just need to know the class, position, and the sound and the size of each object. So this problem is popularly known as bounding box algorithm or bounding box detection. So basically, with the help of a box, we are identifying it. We are identifying and detecting an object. Now comes the tasks of semantic segmentation. So what happens here is we classify the object class for each of the pixels within an image, which means that there is a label for each of the pixel. Now, to state it out loudly, this this presentation is just about like this has just one another slide. That's about it. But I'll be walking you through various I'll be walking you from the inception, like from FCN models to the UNet models, alongside a code walkthrough of how to build an UNet architecture using a compilations of various A standard tutorials that I've come across on the internet. So we'll be talking about we'll be walking briefly through some paper discussions, which would be a summary of the papers, basically not the entire papers per se, but definitely post the sessions you can go back and refer to those original papers and read more about the architectures, and also some open GitHub examples we'll be talking about. So heading on to that. Um, Okay, so this is, yes, ma'am.
No, ma'am. I just it went blank, so I just wanted to
Yeah,
confirm if things
I
are
just changed my screen sharing.
fine. Fine.
Good. So okay, so when we are talking about UNet, I mean we are definitely talking about images, and mostly UNet is basically UNet was specifically architected for semantic segmentations and biomedical image segmentations. I mean this was catered towards the medical community more, but this has found profound significance on other sets of tasks over the years of maturity. So UNet is, of course, the name comes from U shape. The architecture looks pretty much U shape, but I'll come to that later. What does UNet specifically entail? But before that, we'll talk about a fully convolutional network. So our image segmentation task, initially we used to go ahead with a convolution or a convolutional neural network, or popularly known as CNN. So basically a fully convolutional network, or an FCN, also popularly known as CNN, was one of the first architectures without fully connected layers. Apart from this fact, that it is used to train an image, it is used to train using images end to end for individual pixel prediction, example semantic segmentations. It can also process arbitrary sized images. So in general, the CNN architecture effectively used transposed convolutions as trainable upsampling method. So of course, like any other neural networks, it has a forward inference and a backward learning inference as well. Now, this is a pre-trained encoder for an FCN. But before we come to this piece of code, we'll talk about a little bit more in depth about the paper. But even before that, we'll talk about what convolutional neural network is all about. Right? Okay. So first of all, we'll talk about what CNN is about and why should we use CNN. Just to put the foundation straight. So CNN, I mean, is is the short form of convolutional neural network, um, and it is used for recognition tasks, image classification tasks as well. It is very close to the basic neural networks or the MLPs or the ANN that we use. Then CNN have learnable parameters, much like any other neural networks. Examples, weights and biases. Okay, so why should we specifically use CNN? So there are certain problems with the feed-forward neural network. Let's say we are working with the MNIST handwritten digit data set, right? So you know that each image in an MNIST is a black and white image with just one channel. So since black and white image, it just has one channel. If it was an RGB image or a colored image, then it would have three channels. So in case of an MNIST data set, we have black and white images uh, of 28 into 28 into one channel. 28 into 28 is the pixel of the image. Total number of neurons in each of this input layer would be 28 into 28, which is equivalent to 784. This can definitely be manageable. Now, consider the size of the image to be way higher, let's say 1000 into 1000 or even more, which means that you would if it's a case of 1000 into 1000, you would basically need 10 to the power 6 neurons in your input layers. Now you understand how big your input, your neuron layer is going to be. So this is, I mean, the network is going to be huge when it comes to 10 to the power 6 neurons, right? And now, as and when your network size increases, it is heavily taxing on the computation infrastructure as well, and it becomes computationally ineffective. I mean, ideally we do go ahead and use GPUs whenever required, but that does not necessarily mean that we need to go ahead and use GPU when we can actually optimize the code on our end and make it run on a CPU. Because uh, at the end of the day, the more we use this compute capacity at a at a massive level, we are also contributing towards carbon pollution of the environment as well. So keeping the big picture in mind, we should not, a good data scientist or a good computer scientist should not go for a compute intensive task until and unless it is absolutely required. Okay, so keep this in mind. This is one of the best practices. Okay, so basically in such cases CNN came into picture, and not just to say computational ineffective, if you can even make the 784 layers, this small amount of network run on your CPU machine, it's going to take hours for you to run and get the task completed. So in this context comes CNN into the picture. So basically it CNN extracts the feature of the images and converts into a lower dimensions without basically losing its characteristics. So in the following example that we'll be talking about here, so you see the initial size of the image is 224 into 224. These are the pixelations and into 3 channels. So it's the input image. There's a reason why I'm explaining this right now, because there's a significant connection what I'm about to explain right now in terms of CNN to the unit that I'll be explaining a while after. So okay, so this is an colored image. We have pixels of 224 into 224, and since it's color, it's a 3-channel image, right? Now if you proceed without the convolution, then you will need 224 into 224 into 3, which is equal to 100 or 352 numbers of neurons in the input layer. Okay, but once you apply convolution, your input tensor dimension is reduced to 1 into 1 into 1000. It means that you will only need 1000 neurons in the first layer of the feed-forward neural networks, and your job would be done. So what's happening here in this image is you put the image pixels, you put it through this is convolution layer, okay, alongside an activation function ReLU. The red ones are the max pooling layer, and here we have the fully connected layer, and then we have the softmax function. Okay, so this is an example of downsampling, wherein we are getting the image, we're putting it through the convolutions, then we are passing it through max pooling layer, and then again convolution, then again max pooling, then again convolution, and then again max pooling. And that's why downsampling, because it's reducing. So it started with 224 into 224, we took a 64 neurons as input, then it downsampled to 112 into 112 into 120. This is the number of layers, the second layer. 64, then goes the 128, then we increase to 256, then we go for 512. But as we are increasing the number of layers, the pixel size is reducing. Okay, and this is a typical example of downsampling. Now, since we covered yeah, so we covered convolution plus ReLU, then we covered max pooling as a definition, then we covered fully connected plus ReLU and softmax. So we'll be talking about what each of this does, like basically define what max pooling would be all about, fully connected layers and softmax. Right now, as I was talking about the image, I'll just take a minute to represent the image. Right, so as I was talking, that the image is a colorful image, hence the most common one being RGB, which means that red, blue and green. So you see it's a colorful image and it has three channels, red, green and blue. All right, now this information is contained into an image, is the intensity of the each channel color into the width and height of the image. So each the intensity of each of these channel colors are basically boiled down into the image height and image width, which will also when we put it into a form of code, when we'll be seeing codes about unit, we'll understand this more. Right, so basically the intensity of the red channel at each point with width and height can be represented into a matrix format, and the same goes for the blue and green channels as well. So basically we end up having three matrices, and when basically these are combined in the form of a tensor. Now, we also have heard about the famous term edge detection when it comes to CNN. So basically every image has a vertical and horizontal edges, which actually combines the entire set of images. Now, a convolution operation is used with some filters for detecting edges. Let's say you have a grayscale image, which is the black and white or the gray image, with dimensions of 6 and 6 and a filter dimensions of 3 and 3. Say, this is hypothetical, okay? So, when we have 6 into 6 grayscale image, convolve with 3 into 3 filters, we get a 4 into 4 image. Now, first of all, it is important to note that 3 into 3 filter matrix gets multiplied with the first 3 into 3 size of our grayscale image. Then we shift one column to the right to end up. After that, we shift one row and so on. So basically, we are using this filter for each of the pixelations of the images, and then we are moving with one stride and hence propagating through the entire set of pixels of the images. Okay, so this is the filter, this is the image, and this is the outcome of the filter. So this is how it's happening. You see, this is the image and this is the filter, and it's being applied. Okay, so basically the convolution operations can be visualized in the following way. We have an image dimensions of 4 into 4, this is the image dimensions, and a filter dimensions of 3 into 3. You see all the matrices in the blue box is 3 into 3. Hence, we are getting an output of output after convolutions is 2 and 2. So basically, if we have an n into n image size and f into f filter size, then after convolution, the results would be something like n into n into f into f, which is n minus f plus 1 into n minus f plus 1. This is a simple formula calculating how this is working out. Okay, now I just mentioned about stride, and something that comes along is padding. So basically, stride denotes how many steps we are moving in each step of the convolution. By default, it is 1. So this is stride of 1. So you see what's happening here is, it's for the filter is first in this 3 image, and then it's leaving stride of 1, and then it's in this 3 image, and then it's going another stride of 1, unless it is running out of filter. So you see 1, then 2, then 3, then again it's leaving a stride here 1, and then going in this way, and then again leaving a stride of 1, and then going this way. That's how it's covering the entire set of images of the feature map of the images. So what we can observe here is that the size of the output is smaller than the input. To maintain the dimensions of the output, as is the case in input, we basically use something called padding. So this is stride 1 with padding. Now what's happening here is, as I told you, now once your 3 into 3 filter is reaching out here, you see it's no longer moving towards the right, and also it's losing, it's also not coming down once it's having a 3 into 3 filter this side. So in order to cover the entire set of image properly, we use something called padding. So basically, padding is a process of adding zeros to the input matrix simultaneously, symmetrically. In the following example, basically, here this is the image, the blue border is the image, and we have added a padding of 1 to the image. So now you see the filter is running through the padding as well as the image, so it's covering the image in a better way. And so if we in code, when we code, if we keep the padding as same, that means we are basically telling the code to give the output of the image in the same dimension as your input, right? Otherwise because of CNN, you might get an image which is smaller in size, right? So what's happening here is, in this example we are adding an extra gray block which is denoting the padding, and this is basically used to make the dimensions of the output same as the input, which I just mentioned right now. So if we consider P as the padding, and if we use the initial formula, which is this one here, n into n, n plus n, sorry, n into n, and then that gets multiplied with the filter, so we have n minus f plus 1 into n minus f plus 1. Now after applying padding, we have n plus 2p, so we have added 2 paddings into multiplied by n plus 2p, and this is the filter. So we have an n into n image. Why? Because we have n minus f, then what's happening here is we have a filter of f into f which is equivalent to this one, but only difference is, instead of n into n, we have since we have added padding, so we have taken the padding inputs as well. So n plus 2p, this is, we are not multiplying the padding, we're just adding the padding, hence n plus 2p and n plus 2p. So this becomes the input matrix with padding. Then we'll get the output matrix dimension as n plus 2p minus f plus 1 into n plus 2p minus f plus 1. So now we know that after applying padding, we'll get the same dimensions as the original input dimensions. So basically this is standing to be equivalent to n into n. Then after simple calculations, everything gets negated, and we are left with, this is the formula of the padding, and then we will get an image which is equivalent to the size of the original image. Now, talking about the layers of CNN, CNN has various layers like input layer, convolutional layer, pooling layer, fully connected layer, softmax layer, and softmax or logistic layer and output layer. So while we cover those, I just want to make an announcement that if you have any questions, you can either put it in the chat, or I think you can unmute yourself or put it in the Q&A section. Okay, I don't think we have any questions, so we'll just move on. Okay, so talking about the input layer. So the input layer in CNN should basically contain the image data, and image data is represented by three-dimensional matrix, as we have seen earlier. Then at some point, you basically need to reshape it into a single column. Supposedly, you have an image of dimensions 28 into 28, which is 784. Then you need to convert it into a dimension of 784 into 1 before feeding it to the input. So if you have M training examples, then your dimensions of the input would be 784 into M, 784 comma M. Next is the convolution layer. So basically, this layer is also sometimes known or called the feature extractor layer, because this layer is responsible for extracting the features of the images. And what we need to know is here, in this layer, the part of the image is connected to the convolution layer to perform convolution operations, as we have seen the operations earlier, right? And also calculating the dot product between the receptive field, which is basically a local region of the input images that has the same size as the filter. Okay. Next, basically, the result of the operation is a single integer of the output volume. Then we carefully slide the filter over the next receptive field using that stride, right, of the same input image using stride, and we do the same operation again. We do the same convolution operation again. Then we'll keep on repeating the same process again and again until we go through the whole image. And the output will be, the output of this convolution layer would be the input of the next layer. So one thing to note here is that convolution layer also contains ReLU activation to make all the negative values to 0. Okay. Next comes the pooling layer. So what's happening in pooling is, okay, so pooling layer is basically used to reduce the spatial volume of the input image after the convolution. So this is used between two convolution layers. Now, let's say if we apply a full convolutions after a convolution layer without applying a pooling or a max pooling, then it will be immensely computational expensive, and we basically don't want it. Hence, we put a convolution layer, then we put a max pooling layer, and then if need, we can put the fully convolution layer. So basically, max pooling layer is only the way to reduce the spatial volume of the image. Now, in this above example, we have applied a max pooling layer in a single depth slice with stride of 2. This is no longer stride of 1. This is a stride of 2. So it will jump 2 rows, 2 pixels ahead once it moves on. Therefore, you can observe the 4 into 4 dimension input is reduced to 2 into 2. So we have applied a 2 into 2 max pull filter with stride 2. So your first filter goes here, then your second filter goes here, then third filter and fourth filter. Hence, we get this image of 2 into 2. So this color is basically the filters. First time the filter is here, second time the filter is here, third time the filter is here, fourth time the filter is here. And we are getting the output of each of the filters in color coded format, right? Now, once this is clear, now all you need to know is that there is no parameter in the pooling layer, but it has two hyperparameters. One is a filter and the other is a stride. Now, let's say if we have an image of input dimensions of height, width, and D1 dimensions, W1, H1, D1, then W2 would be W1 minus the filter divided by the stride plus 1. Your next height would be H1 minus filter divided by stride plus 1. Your D2 would be equivalent to D1. Okay. So W stands for width, H stands for height, and D stands for depth. Next is the fully convolution layer, which we have seen here, blue lines. Okay. So what we covered so far, we covered the convolution layer and then we covered the dead max pooling layer. Now we'll cover the fully connected layer, fully FC, then we'll cover softmax and then we'll cover output. So what's happening in fully connected layer is this basically involves weights, biases, and neurons. It connects neurons in one layer to neurons in another layer. Okay. And it is used to classify images. Okay. My voice is breaking. Is it for everyone?
Your voice is not breaking, Proud.
No, ma'am, it's clear.
It's very clear.
Okay. Okay. So,
Ma'am, I would like to take opportunity to ask a question since it's a break. What is the difference between DNN and CNN? I mean, deep neural network and convolution neural network.
okay. So, deep neural network is something that we use for deep learning neural networks. CNN is specific to the architecture that we are speaking about right now. So deep neural network is a term that is used generally across the deep learning neural networks. Okay. And
so can we say that this is the one of the, a subdomain of DNN? CNN is a subdivision of DNN. Can we say this?
okay, I won't say subdivision, but it's a type of. Anyway, like you have artificial neural network, it's a type of DNN. We have
Yes.
sorry, there's a background. Someone else was speaking as well. So yeah, so I was saying that we have RNN. RNN is an architecture, right? We have LSTM, that's an architecture. We have
Right.
CNN. CNN is an architecture. All of these are kinds of deep neural networks.
Okay, fine. Got it. Thank you.
Yeah. Okay. So, okay. So talking about the full, oh, ma'am, so I think someone is facing issues with my voice. I think it's a network issue from your side, ma'am, in that case. If it is audible to everyone, then I don't think my network is an issue at the moment. But maybe change your network and see. If not, please feel free to put it in the chat. Okay. So in this fully connected layer, this basically involves the weights, biases, and neurons. It connects the neurons in one layer to the neurons of another layer, and then it is used to classify the images between different categories by training. Then we have the softmax layer or the logistic layer. So softmax or the logistic layer is the last layer of the CNN. So it resides at the end of the fully connected layer. Logistics is used for binary classification problem, and softmax is used for multi-class classification problem. Clear? So when we are using CNN for binary classifications of images or binary segmentations, then we use logistic layer, and if you are using it for multi-class, then we use softmax layer. Okay, and then finally the output layer, which contains the label, which is in the form of one hot encoded. So now that we have a good understanding of CNN, we can definitely go ahead and implement a CNN using Keras. But that's probably not the scope of this. If we have time at a later point, beyond this session, we'll come back and show you. But what I'll show you right now is a basic CNN layer, and how you can code it using Python. Okay, so this is using PyTorch. So what's happening here is we are creating our very own fully convolutional neural network. Okay, even before this, I had to show you this paper. By the way, so CNN comes from this paper, fully convolutional network for semantic segmentations. I mean, this is the first one, and then beyond this, on top of it, we have UNet, and then we have various variants of UNet as well, segmentations. And this paper became very popular in 2015 CVPR. CVPR is a conference. And then also again in 2017 TPAMI, this is also a conference and has been cited for more than 6,000, and this blog itself was written in 2018. So back in 2018 it has been cited more than 6,000 times, and now it's 2021, it has been cited more. Okay, so what's happening here is so this is one of the very basic paper of semantic segmentations using FCN, and the topic for today is semantic segmentations, not classifications, not detection. um, so okay, so what's happening here is from image classification, so from classification to segmentation, what's happening here, we talked about the convolution layer and also the fully connected layer. So in classifications, conventionally, an input image is basically downsized and goes through all the convolution layer and then to a fully connected layer, and and
तो नहीं मंगवाया नहीं, मैं वही पूछ रहा हूँ।
there's a background
टीम
noise.
में है नहीं?
Mute yourself.
अच्छा, चलो ठीक है।
Ma'am, if you could mute the participants, that should be
अच्छा,
fine.
क्या है? तो दूध नहीं भेजा?
Ma'am, are you there?
चलो ठीक है। हेलो, हाँ जी, गुड मॉर्निंग शनि।
All right. Thank you. Okay. So in this classification, conventionally, what's happening is an input image is downsized and goes through all the layers of convolutions until it reaches the fully connected layer, and the output is basically one predicted label of the input image. So this is an image with pixel of 227 into 227. It goes to the convolutions layers. It downsamples. It decreases in size as we were talking about here, right? I think this was the one. Anyway, so this is the same image as well. So it downsizes, and then finally it passes to the convolution layer, and then we get the predicted label of the input image. Now imagine if we turn this fully connected layer into one convolution layer. Now this fully connected layer is converted into a convolution layer again. So now the pixel of the images is going through convolutions, it's downsampling, and then it's going through one-to-one convolutions. Okay, now what's happening is another thing to consider is if the image is not downsized, that means the pixels are not reduced, then the output definitely will not be a single level. Instead, the output has a size smaller than the input image due to the max pooling layer. Now, if we upsample the output, which is we are increasing the pixelations, then we calculate the pixel-wise output label map as this one. Okay, so we have height and width of the image. We pass it through the convolutions layer, then we upsample it, and then we get the pixels like this. Okay, so this is the thing that you're seeing right now. This is a typical example of segmentation. Okay, so to reiterate the fact, what's happening here is at the very first layer, through downsampling, we are just predicting one label of the image. That's it. I mean, it's a dog or a cat. We are just identifying that through one layer of through when it's passing through downsampling convolution layer. Now, and then passing it through a fully connected layer. Now we are at the second layer, we are not connecting it through we are not passing it through fully connected layer. Instead, we are converting the fully connected layer to a 1-into-1 dimension convolution, and we are also not downsizing the image. Then in that case, we get all the pixels. Then we don't get the single label as this one, but we get all the pixels, and the image size is definitely reduced because we are already passing it through max pooling layer. But next step, if we upsample that image, that is keep on increasing pixelations, then we get an output something like this, wherein we are performing the segmentations. You see, there are two there are two animals here. I think a dog and a cat, and it is easily performing the semantics layer of segmentations and highlighting the images. Okay, so you have a dog and a cat, and then you perform this, and then you get a segmentation, pixel-wise predictions and a segmentations. So now one thing to note is that upsampling via deconvolution. So so some things to note about here is, so convolution is basically a process of getting the output size smaller. Thus, the name deconvolution is coming from when we want, basically deconvolution comes into the picture when we have the upsampling to get the output size layer. Again, I'm just reiterating the fact. The reason I'm explaining you this in depth is because this has direct connection with the unit architecture as well, that I'll be explaining in a while. So basically in this, in convolution, what's happening is we are reducing the output size. But when we're talking about deconvolutions, that means we are upsampling to get the output size larger. But okay, so usually deconvolutions from the name, it can easily be confused with just the opposite of convolution, but it is not. But on the contrary, deconvolution can be called as upconvolutions or transposed convolutions, or upsampling or transposed convolution when it comes to a convolution network. So again, we'll talk about transposed convolutions when we cover the unit architecture a little more in depth anyway. And it is also called fractional stride convolutions when fractional stride is used. Okay, next is now fusing the output. So what's happening here is, you see, so here it has 7 layers of convolution. So after going through 7 in this particular image, it's a FCN32S. So after going through 7 convolution layer, the output size is small. Then 32 into 32 upsampling is done to make the output have the same size as the input image. But in this case, if we do this, it also makes the output label map rough, and it is known as FCN32. We'll see the code of this architecture, FCN32 architecture, in a while. So you see, this is an image with input pixelations. Then we have convolution layer 1. Then we have pooling layer, convolution layer 2, pooling layer 2, convolution layer 3, pooling layer 3. Then fourth convolution layer. Then we have another pooling layer. And as you see, the pooling layer is also, increasing. Increasing as in, so, okay, so what's happening here is you pass it through, let's say your image is 28 into 28, you pass it through 28, okay, let's take 128, you pass it through 128 convolution layer, 128 to 128, then it reduces down to 64, then in the next convolution layer it reduces down to 32, then in the next convolution layer it reduces down to 8, so on and so forth. And then here we are upsampling it with again a 32 with 32 upsampling, and that's how we are getting the upsample prediction image, the segmented image. Okay, this is because deep features can be obtained when going deeper. Spatial location information is also lost when going deeper. Okay, so deep features of the image can be obtained when you go deeper, and all, but one thing to note is that spatial location information is lost when going deeper. This means that output from a shallow layer have more location information. So if we basically combine both, we can enhance the results. Now, in case of an FCN 16 or FCN 8, they are combining both, but I won't be covering this in depth. Or maybe I'll just talk about this a bit, because when we are talking about this combination, this is a very messy combination kind of a thing, and UNet has basically cleared that mess out, and it gives a clear architecture. So okay, so just talking about this a little bit. So when we fuse the output by element wise addition, we have pooling layers, then we have the upsampling layer, and then we pass the pooling to an 2x unsampling prediction. We pass this to pool for prediction, then we make a summations of it, and we get a 16x upsampled prediction, which is FCN 16S. And then again we pass the output of this to a 2x upsampled prediction, and pool 13, this is passed through pool 3 prediction, and then we get an 8x upsampled prediction, which is FCN 18. So in FCN 16S, the output of the pool 5 is 2x upsampled, and this fuses with pool 4 and performs 16x upsampling. So similar operation is carried on for the FCN 8S as well in this figure. So this is how you get the output of FCN 32. Then you see FCN 16S, then you see FCN 8S, and then this is the ground truth. A lot better segmentation. Now the image in this case was different. It's like humans riding bicycle, not the cat and the dog. This one. Okay, so this way you get a much better segmentations. Now FCN 32 result is very rough due to the loss of location information, while FCN 8 has the best results. Okay, this fusing operation actually is just like the boosting or ensemble techniques that is used in AlexNet architecture or VGGNet architecture or Google LaneNet architectures. So these are all again various architectures, deep neural network architectures. Okay, so when they add the results by multiple models to make the predictions more accurate, but in this case specifically, it is done for each pixel, and they're added from the results of different layers within a model. Okay, now we'll look into the code of FCN 32 here. So we are defining the architecture. We're defining it using a class FCN 32. Yes, and we are using the nn.module method of PyTorch. Since we are importing torch, torch.nl, nn is the neural network module of PyTorch. So next we define the initialization function. So here we take the self, pretend net, and end class, the number of class of the images. So we're defining the class of the images. We take the pretend net, we define the value, then we define the deconvolution layer, and deconvolution layer, as we saw here, it is basically either up convolution, upsampling, or transposed convolution. So we are taking convolution transpose to D, and then the input filters, the kernel size, the stride, the padding, dilations, and then we are adding one batch normalization layer to it, and then we are defining the deconvolution layer 2. So this is the upsampling part, just the upsampling part, because in case of segmentations we are using the upsampling part here, right? As explained in this diagram. Anyway, so we are defining the next deconvolution layer. In that case, we are using a filter of, so this 512 is the input filter, and then the output is also 512. So this 512 gets fed here. Then we get an output of, and we put an output of 256 layers. Then we put the kernel size, padding, stride, dilations. Then we add a batch normalization to it again, and then we define the next one. So this becomes the input filter of the next one, and then the size is reduced, and then the rest of the parameters remains the same, and then we offer batch normalizations on this one, and then again the next input layer is this, and the output of that is 64 layer, and then the rest of the remains the same, so on and so forth, and that's how it goes until here. Okay, and then we pass it to a classifier convolution 2D. So note that this is not a transposed convolution, and then we pass it to 32 and in class and kernel size. Now talking about the forward layer, excuse me, we have the output, which is the self pretend net, and then we just take we just define this x5 variable using this, assigning this value output of x5, and this is basically an image, and these are the heights and widths. We are converting the height and width of the images into a floating point variable, so that it can be read through the convolution layer, and then we are calculating the score of each of the batch normalization layer. Code is not visible. Code
Yeah,
is not
visible, ma'am, visible.
So if you don't see the code, if you're using a small screen, then there's an option to, yeah. No, I mean, all I'm saying is there's an option to zoom in. If I zoom in from my side, it gets, cut off. So participants from their side, they can zoom in. Okay, and check the code out.
Right address, no, ma'am. They can.
Oh yeah, absolutely. So these are all available.
Can you post that? Can you post that URL in the chat window, please?
You want
So
me
that
to do
they
it
can.
now, or post the lecture so that everyone can have it as a resource?
Okay.
Okay. So post the lecture, I'll then send you the
Now,
links.
if you see the
Yeah.
code is very small, not visible, maybe that is the reason they are asking.
So for that, that's what I'm saying. Anyway, I can paste it in the chat. But for that, I'm saying that if you could zoom in from your screen, there's an option to zoom in from your screen, from participant screen on WebEx. Then they can view this as a zoomed code. Or else, what I can do is, okay, from the next one, I'll try to pull in a different format, and then let's see. Anyway, so okay. So this is this code that we are calculating, and this is typically how we are coding on FCN32 architecture. Now coming to unit or unit and then 3D unit. But before that, I'll just take a minute of pause, and if there are any questions or discussions, feel free to ask me or put it in the chat. I'll just drink some water and get back. Any doubts or questions or anything related to what I've just said, feel free to put it in the chat, or unmute yourself. We can have a discussion. Ma'am, just quick questions. How long would the session be? Is it till 11 or 11:30? Anupriya ma'am?
Sukanya,
Yes. Hello?
Yes, ma'am. Yes. Hello.
Yeah, ma'am.
Yes,
So
ma'am.
I was just asking you, how long would the session be? Is it till 11 or 11:30? To 11:45.
Yes, ma'am. I'm not able to hear you. I'm having some issues here. Yeah, yeah. Up to 11:45.
Okay, I think I'll be wrapping it up by 11:30. Okay. All right. But
Here,
okay.
I'm not here. I'm not able to hear you properly. I'll give you a call if you want. I'll mute and I'll give you a call.
No, that's fine. I said I'll just be wrapping up by 11:30 probably. Yeah.
No problem. No problem. No problem, ma'am.
Yeah. All right. Thank you, ma'am. Okay. So now we have spoken enough about the FCN architecture. Now, basis that, we'll be talking about the unit architecture. So the name basically comes from the U-shaped architecture that you are seeing. But at the end of the day, here we are doing something similar to what we were doing in case of an FCN architecture as well. Okay. So what's happening here is, you see this is unit, U-shaped architecture. All right. So we have an, let's say we have an input image, colored image of pixelations 128 into 128, and since it's a colored image, it will be a channel of 3. So we'll have 128 into 128 into 3. This is the input size of the image. So this particular layer at the very left is the input layer. Okay, this is where you're putting in your image. Now next to these two are the convolution layers. So we pass it through 16 filters, and at the very first convolution layer we have 128 into 128 into 16 layers, 16 layers of convolution. Okay, so this is C1, denoted as C1. Now as we have seen in the convolutions layer of CNN, the output of the first convolution goes to a pooling layer or a max pooling layer. So this on the left hand side, P1 is a pooling layer. Okay, so we apply a max pooling filter of 64 into 64 into 16. Then post pooling, then again it goes through layers of convolution. So we take this to filter stride, and then we pass this to the we take this layer input. So 64 into 64 into 32. Next again, the output of this goes to a pooling layer. Next we have here pooling layer is 32 into 32 into 32. So this is increasing the layers in the pooling. All right. So, and then after this pooling, it goes through another layer of convolution. So here we have 32 into 32, and this layer is increased to 64. Okay. Then we have another layer. Then we pass the output of this to another pooling. So next we have this 16 into 16 into 64. Okay. And then we pass it through we pass the polling output to another layer of convolution, and here we have the convolution filters as 16 into 16, and the number of layers is 128. We pass this to the next polling layer, and that gets reduced to 8 into 8 into 128. And now if we have here we have a layer of 256. So this gets passed on here, and this gets passed on to the next convolution layer. Now, before I begin this line, I just want to talk a little bit more about this part. So on the left hand side, this part is known as the encoder. So this is basically downsampling the image, which happens in a general CNN. Okay. This part is the bottom layer. The input, you see this array, this blue array, the convolution array, has a convolution of 3 into 3 with ReLU. Everywhere the padding is used to be same because we need a similar output image as the inputted image. The max pull filter is 2 into 2, and the number of stride we are using here is 2. Okay. Now this part, we covered the downsampling part. This is the bottom layer. Now we have a max pull of dimensions 8 into 8 into 128. 256 layers are passed on here until it goes on to the next convolutions. And now this path on the right hand side is the upsampling path. This is also known as the decoder path. Okay. So what's happening here is we are deconvoluting whatever we have convoluted here. So we are upsampling the image to get the final output of the segmented image. So here we start with the convolution layer C5. It begins with 8 into 8, and since we had a filter here, number of layers is 256, it starts with 256. And then we pass this here. So you see, follow this black array, it goes to this dark blue layer, and then it passes on to the convolution layer. Now before I talk about this, I want to talk about this array. This is what makes UNet exclusive. These arrays are the one that makes UNet exclusive. So what these arrays are doing is basically, once it comes to the bottom layer and it starts upsampling, it is also taking the feature learned from each of this downsampling part and is adding on to this convolution layer. So what's happening here is, let's consider this as upsampling layer 6, or the final output to be convolution layer 6. So the upsampling layer 6 would be a combination of, would be an addition of upsampling layer, would be an addition of upsampling layer 6 plus the convolution layer C4. So the convolution layer is giving an input of 16 into 16 into 128, and this is, and U6 is basically coming out to be 8 into 8 into 256. So it takes an overall of 16 into 16 into 256. Okay. Then it passes
like quantization algorithm. Here,
sorry.
Hello.
Yeah. Someone tried saying something.
Ask it slowly, or you post it in the chat. Ma'am, you proceed. I think I'll mute all.
Sure. Thank you. Okay. So this convolution layer 6 starts with 16 into 16 into 256 layer input. All right. And then the number of filters, number of layers, again from 256 is reduced to 128. Okay. And the output of this convolution is then again passed through this upsampling layer. So here we are passing 32 into 32 into 64 and adding again this 32 into 32 into 64 with this. So we have a filter of 64, and hence our seventh convolution layer is also 32 into 32 into 64. Now we pass this here. So we have, so what's happening here is, you see, because of upsampling and because of the max pole of 2 into 2 and stride of 2, the pixels of the images are increasing from 16 into 16 to 32 into 32, and then from 32 into 32 to 64 into 64. But the number of layers, this 128, 64, 32, is reducing. Okay, so what's happening here is we are putting the input of C7 to 64 into 64 into 32, and then adding the input from here as well. Again, that is 64 into 64 into 32, and finally we are getting an output of 64 into 64 into 32. Now this again is passed to another layer. Okay, and here we have 128 into 128 into 64. Sorry, 128 into 120. Now this upsampling layer is passed through this one, U9. So it's 128 into 128 into 16, and also this gets added, 128 into 128 into 16, and then it's passed through again a 16 layers, and these are the convolutions, 3 into 3, and then this is the final convolution layer of 1 into 1. So finally we get an image of 28 into 128 into 1. We get the segmented output here. So this is precisely there's a question. C5 output is considering or not? I didn't get. Yeah, C5 output is being considered here. And then it is added. C5 output is considered here. The image goes here. And then it is added up with the C4. This is upsampled. So C5 is an output of 18 to 18 to 256. Then it is upsampled. It is upsampled with 2 into 2. Hence it gets 16 into 16. And the number of layers are being reduced. So we have 16 into 16 into 128. Here is a mistake. 16 into 16 into 128. And then we are adding 16 into 16 into 128 to this. And then we are passing it through these two layers of convolutions. And then we have 16 into 16 into 128. So this way, C5 layer is considered here. So anything that comes on from here goes until the bottom layer, and then again from there on, it starts upsampling, and everything is considered. Did that answer your question, Srinivas? You can put it in the chat maybe, if that answers your question. Anyway, okay. So this is typically how semantic segmentations is occurring. Okay. Now we'll look into the code, but before that, we'll look into the code of this unit, this very specific architecture of unit, using Keras. Ma'am, could you please answer if I've answered your question or not?
Oh,
Maybe
yes,
in the
ma'am. It's
chat.
clear, ma'am. Thank you.
Thank you. Okay. I'll just again change my sharing. Are there any further questions so far? Please feel free to ask right now. Okay. I believe there are no questions so far. So, oh, one sec. Yeah. So okay. So here is a PyTorch implementations of the same, and I'll also show you a Keras implementations of the same. Okay. Okay. So here just summarizing what we have covered in the architecture. So we have encoder on the left hand side, and we have decoder on the right hand side. So encoder basically it consists of repeated applications of 3 into 3 convolutions. Each convolution is followed by ReLU and batch normalization. Then 2 into 2 max pooling operations is applied to reduce the spatial dimension. Okay. Again, at each downsampling step, we double the number of feature channels while we cut in half the spatial dimensions. And on the decoder side, on the right side, every step in the expansive path consists of an upsampling of the feature map followed by a 2 into 2 transpose, 2 into 2 up convolutions or transpose convolutions, which halves the number of feature channels. We also have a concatenations with the corresponding feature, okay, map with the corresponding feature map from the contracting path, and usually a 3 into 3 convolution, each followed by a ReLU. At the final layer, a 1 into 1 convolution is used to map the channels to the desired number of classes. So this is basically an input of 2D UNet. So what happens here is, so we have a double convolutions NN module. Again, we define the convolution layers with batch normalizations to ReLU. We define each of the convolution layers with the input channel, the output channel, the kernel size, and the padding. And for each of the convolution layers, we apply batch normalizations. Then we also apply the forward loop to it. And then we have the input convolutions. We define the input convolutions here, self, in channel, out channel. Using this, we convert the. I think I can increase this size. Yes. So okay. So here we define the input convolution class, we define the initializations and the forward loop, and then we define the downsampling class as well. So here what we are doing is we are passing it through sequential layer and then doing a max pooling 2D max pooling, and then we are doing a double convolutions, input channel and output channels, and then the feed forward, and then the upsampling part. So this basically is the upsampling layer where we are initializing the upsample layers, scale factor of 2, more bilinear, and we are defining the channels, we are dividing those by 2, and then we are keeping a stride of 2, and here, excuse me, we are defining the forward function and the forward pad as well. So this is the upsampling, this is the down path, this is the in convolution layer, and this is basically the double convolutions layer. And then beyond that, we have the out convolution layer after the upsampling layer, where we are defining the necessary parameters for the out convolutions layer. And then we finally define UNet using all of these that we have defined above. So we define a superclass UNet, and then we specify the channels in the class, and then the in convolution layer or the input channels. Then we do the downsampling, then downsampling through all the layers, and then we do upsampling, and then finally we have the output convolution layers. Okay, and then we are doing is the forward path. Forward path for each of the convolution layers. That is it goes through convolution, then max pooling, then again convolution, max pooling, it goes to the bottom layer, and then upsampling. So this is what we are doing in case of UNet. So this was a typical PyTorch example of UNet, of 2D UNet basically. So this method has great success in 2D biomedical image segmentations, and it is still used as a baseline method for this case. Now there's another architecture as well for 3D images, 3D UNet, but we'll cover that in a while. Before that, I want to show you TensorFlow Keras implementation of UNit. Is the code visible now?
Yes,
So
madam.
Yes, ma'am.
thank you. So so this code is taken from like this code is, I'm referring this code from Python for microscopist repo, and this repo is maintained by this person, and he has various YouTube videos explaining various deep neural network architectures. Do check out his channel. And I found this tutorial to be extremely helpful to understand, to explain basically how to code 2D unit using TensorFlow. Okay, so we just import TensorFlow as TF, but that's like the obvious step. Here, what we are doing is we are taking, this is the image input. So what's happening here is it's again an RGB image. So the input of this image is basically image width, image height, and image channels. So we have 128 into 128, and then we have a 3-channel image. So this is the input layer. This is the input image height, width, and channel. Now here we are building the model. Just remember the architecture that I've explained, the U-shaped architecture here. Okay, so what we are doing here is, okay, so we are passing the first is the input layer. So we are passing the input size of the image to TensorFlow Keras layers. We are passing input height, width, and image channels, and then we are converting the image to a floating point variable, the height, width, and width of the image to floating point, so that it can be fed into the convolution layers. Okay, and this is basically S. We are defining a variable, and we are applying this lambda function on this input. Now, once we have this input up and running, then we'll take this to convolution layers. So we'll take C1 as the convolution layer. It's a 2D convolution. So we'll apply filters 16 into, it's a 16 filtered. We'll apply 3 into 3 convolutions. We'll apply a activation function value. We'll apply the kernel initializer, which is the H in normal, and then we'll apply padding sim, because at the end of the day we need the input output image to be at the same size as the input image. Okay, and then we are applying these convolutions on this S. Next, we define a dropout layer to each of the convolutions. We define a dropout layer to each of the convolutions, and point 1 basically denotes that we just randomly drop out 10% of the entire set of data. That's it. And then there's another convolution to it. So we apply that as well. Same 16 filter, 3 into 3 convolutions, activation function value, kernel initializer, H normal, padding same, and this is applied on C1. Now the output of this goes to a max pooling layer here. So what's happening here is we are applying this to a max pooling layer of 2 into 2, max pool of 2 into 2. Okay, next again the same convolution starts. This time we have a filter of 32, but the convolution is 3 into 3. We have convolution layers, input layers of 32, but the convolution filter is 3 into 3. Activation value and kernel and padding remains the same, and this is applied on P1. Why? Because the output of this is fed into this, and then the output of this is fed into this, and then this. This is how it's working. Okay. So similarly, and then post that we apply another dropout layer, again 0.1, 10%. Then we apply the C2. C2 is like TensorFlow chaos convolution 2D. This is the again the same layers, and then convolution filters, activation function, all rest remains the same basically. Okay, and then this is applied on C2, this one, and then it goes to P2, max pooling layer 2, and this max pooling layer 2D max pooling layer is applied on 2 into 2 C2 here on this one, and then in the next layer this P2 gives the output to C3, but in this case we are using 64 layers, rest remains the same, and it is applied on P2, and here we are just using a dropout of 0.2 instead of 0.1, and then we have another convolution, same configurations, and then the output of which goes to P3. So max pooling layer 2D, again 2 into 2, that is applied on C3. Then in the next convolution of C4, next convolutions of C4, this gets increased to 128, but the rest remains the same. And again, the dropout is 0.2, and then we have another layer, again C4, another convolutions, and then that is getting the output to P4. Okay, P4 again same max pooling 2D pool size of 2 into 2, and then comes the C5, the bottom layer, or if you remember that diagram, so we have the C5, which is the exact bottom layer. So here we take the convolutions to be 256, then it comes 3 into 3, and the rest remains the same, 3 into 3 filters, just that we are using a dropout of 0.3 that is applied on C5 layer, and then again another one, right? And then the output of C5 now goes to the upsampling part or the expansive part. So so we have U6. U6, you remember, it's a combinations of U6 plus the C4, right? It's a combinations of U6 plus C4. So here we have this convolution 2D transpose. You can either use upsampling or convolution 2D transpose method here. So now from 256, this is reduced to 128, and this goes to a max pooling layer of 2 into 2, sorry, upsampling of 2 into 2. I think it's there on the other image. Upsampling layer of 2 into 2. Yes, upsampling layer of 2 into 2, and padding remains the same and strides 2 into 2. Then we have U6 again. So what happens here in U6 is, again, we are just concatenating the U6 to C4, okay, and then that's how we are getting the C6 layer, both the C6 layer. We are also adding a dropout in between. Okay, the rest of this part remains the same. Okay, then we have U7, similarly to U6, only this will be 128 will be reduced to 64, and rest remains the same. Only U7 here, it's being added to C3. Why? Let's say if this is U7, then it gets added. Let's say if this is U7, this gets added here. If this is U8, this gets added here. Okay, so similarly for U8, it happens the same, and U9, it's also happening the same. Only thing is that here in this case, it was increasing from 16, 32, 64, 128 to 256, and then again it started reducing from 256 to 128, 64, 32, and 16. And finally, we have the output convolution layer, which is a fully convoluted layer of 1 into 1 and an activation function of sigmoid. So you remember while covering this CNN part, we told that we'll be using logistics for binary classifications, and in case of multi-class classifications, we'll be using sigmoid. And this is applied on C9, okay, C9, which is this layer. Then we have the final model, ts.kls model, inputs, and then the outputs. Okay. And then we have a model.compile optimizer. We are taking optimizer as Adam. There could be other optimizers, but Adam is proven to perform best. We are taking a loss function, binary cross entropy. We also need the metrics, accuracy metrics. And then here we are printing out the model summary. Now with this, I'll show you one example use case. But before that, I'll just stop sharing for a minute and would like to ask you if you have any questions. Please feel free to put it in the chat. I'll just go on mute for a while.
Participants, if you have any doubts, you can post it in the chat window so that Ms. Kanya can address it.
Ma'am, I have a
Madam,
doubt.
I think there is
Is it
one
similar
by
to
Dr. Harshit. Okay, proceed, Ms. Devi.
ma'am, I have a doubt. Is it similar to encoder and decoder? Yesterday, I have attended a session. In that, they explained about encoder and decoder, compression and decompression. Is it similar to that, ma'am?
I mean, it's following a similar kind of a concept, right? But it is more in terms of the architecture, it is more similar to CNN. It's just when we are talking about the encoder and the decoder part of the unit, right? So on the left hand side, it's basically the contraction, and on the right hand side, it's basically the expansion. Why we are calling this is because we on the left hand side, as I told you, we are reducing the image pixel size. Let's say we are using the 128, we are starting from 128 into 128, right? And then we are reducing it to uh, a pixel size of 8 into 8, and then again we are increasing on the upsampling part, we are increasing it again back to 128 from 18 to 8, right? So I mean, yes, ideally encoder and decoder by definition it is similar, but in terms of architecture, it's more how it is working, it's more similar to the CNN. Does that answer your question, ma'am?
Yes, ma'am. Yes, ma'am. Thank you. And another question, ma'am. Semantic segmentation and instance segmentation, both are there, ma'am. What is the difference, ma'am?
Right, right. Okay. I think it's best to explain that uh, with an image. But okay, let me pull that up. I'll just talk about that a little bit in a while, if that's okay. Yeah. Let me pull up an image to show you
Ma'am, there
semantic
is
segmentations versus.
okay, ma'am. You proceeded. After that, I will ask. There is some question in the chat also.
You can
You
definitely
finished
ask.
that, ma'am?
No, you can definitely ask the questions right now. I mean, this is what I've paused
No,
for.
ma'am, it's from the chat only. Yeah, it's from
Mhm.
the chat only, madam.
Sure.
They are asking to explain what is the difference between 32S and 16S. See, you can see by from Dr. Harjit.
Hmm. Okay. So what's the difference between 32S and I unfortunately don't see that, I think. I don't see that in the
I'm
chat
just
window.
posting it again. See, I'm posting it again, madam.
Oh, yes. Yes, now I see. Now I see
Mm.
the image. Okay. Yeah. Mm. Yeah. So can you please explain what's the difference between 32S and 16S? Okay. Fine. So then in that case, I need to go back to the architecture once more of the CNN. Okay. Any further question? Anyone else? Anything?
No, ma'am. Yes, only this much has these questions have been posted, ma'am. Thank you. What is your plan, ma'am? Are we going to continue?
Yeah, I'll just answer these questions and then I'll continue. Yeah.
Okay, fine, fine.
Okay. So talking about semantic segmentations and instance segmentations. Okay. So here you see, let's say you have an image of 5%. All right. In semantic segmentations, it just detects the objects, it segments the objects from the background, and it is just like person in general. Okay, this is semantic segmentations. Now on the right hand side you see instance segmentations. What's happening here is it is clearly defining person 1, person 2, person 3, person 4, person 5. Okay, so in image 1, in this one, each pixel belongs to a particular class, either a background or a person. Okay, also all the pixels belonging to a particular class are represented by the same color. Background is black and the person is pink. This is an example of semantic segmentations. Now in image 2, also this also has assigned a particular class to each of the pixels of images. However, the different objects of the same class have different colors. Okay, person 1 is red, person 2 is green, background is black. So this is basically an example of instance segmentations where we are clearly able to segment between each of the instances. Does that answer your question, Sireni?
Yeah. Okay, ma'am. Thank you very much.
Thank you. Okay, now coming back to FCN 32 and FCN 16. Where did I cover? I think I lost. Oh, here. Yeah. Okay. Okay. So in case of FCN 32, you're applying a 32x filter of upsampling. And in FCN 16, you're applying a 16x filter of upsampling. Now what's happening here is, in such case, when we are using FCN 32, it is way more in depth. You see, we are obtaining deeper features, but spatial location information is lost. In case of FCN 16, you see the image, the spatial location image or the loss of the location is reduced, and it's giving a better output, segmented output than your FCN 32, which is further improved with FCN 8S. So S is basically the stride layers, as we saw in UNet. In case of in CNN, it's just taking up the pulling input and then passing in through the upsample prediction. This is just about it. I mean, at a high level, this I can okay. Someone, okay, fine. This at a high level is the difference between FCN 32S and FCN 16S. In case of 32, we are using an input sampling, upsampling of 32 filters, 32x, and in case of 16, we are using 16x. The difference that we get is in 32x we are exploring more deeper features, but in terms of doing that we are actually losing the spatial locations of the images from the images. And in case of 16x, we are just not going in as deep as 32, but that is giving us the benefit of maintaining the spatial locations of the images. Does that answer your question, sir? If you're still in this room, could you please post it in the chat or something like that? Okay. Ma'am, the person who asked the question, is he there? Anupriya, ma'am? Am I audible?
Yeah, you're audible, Sukanya.
Okay. Anyway, so I think yes. Okay, I'll just move on then in that case. Okay, so sorry, someone is speaking.
Audible, ma'am.
Ma'am, if you're trying to speak, I think your voice is breaking. Okay, so I'll move on to another example. UNet nuclei segmentations using UNet. So I'll talk about the data set a bit before even proceeding to this. Okay, so then again, this example is taken from the same repo as the previous Keras example. And there are a couple of YouTube videos, nice YouTube videos that walks through this example in depth. So in this example, we'll be using this data sets. So Data Science Bowl 2018 from Kaggle, and so you have mainly will be using these two, stage 1 test and stage 1 train. So all you need to do is just download these data sets into your local repository, or if you're using Google Colab, just download it from your My Drive and just get it up and running. So after download, post download, you would need to unzip the data, and then work. You would need to unzip the data, and then after post unzipping, you'll get two folders: stage 1 underscore test and stage 1 underscore train. You'll get two folders. Okay, so in each of those folders, okay, so in each of those folders, you will get, so in the stage 1 training folder zip, let me see if I can download it, like okay. Here, okay, fine, good. It's explained here. So in this stage 1 training, folder inside, you will have two folders. One is images and one is mask. So image contains one RGB image of numerous cells, and in the mask folder, it contains the segmented masks of each nucleus. The folders, this mask folder is only included in the stage 1 train folder. Each mask contains one nucleus. Masks are not allowed to overlap. No pixels belongs to two masks. Okay. The second stage dataset will basically contain images from unseen experimental conditions. This is for you to do predictions. Okay. And in the stage 1 test, these are test sets of images, only images. You're predicting the mask. That's it. So basically, In stage 1 train, you have two folders. One contains the images which will be used to train your model, and one contains the mask which will be used to which has the segmented output. And in the stage 1 test folder, you will just have the images. You will need to use the trained model to predict the masks. Okay, so this is what we'll be doing here in this piece of code. So we'll be using TensorFlow again. So importing TensorFlow, import OS, random. Anyway, here we are just importing the necessary libraries. TQDM. TQDM is to show, we will be doing some basic pre-processing in this image using the image, right? So in that case, we'll be using TQDM to show the progress. So what's happening here is you import all these, and then you just apply a seed of 42 so that your every time you run the experiment, the input or the output does not change. It remains constant, right? And then you specify the image pixel, which is image width and height of 128 into 128, and all of the nuclei images are colored images. So all of the nuclei images are colored image, so it's a 3-channel image. Now we have the train path as stage 1 dot train, as we saw from here, and then we have the test IDs. Test path as stage 1 dot test, as we saw from here, and then in that case okay, so what we're doing here right now is we are reading the images. So we're just using os.walk train path and os.walk test path. So what os.walk does is it goes inside the specified folders and walks through the entire set of the folders. And all we are asking it to do is create a tuple of images that it walks through inside that folder. Okay, and this next is basically iterating through the entire set of images or the image folder, and that's how you are and whatever images it finds inside the image folder, it adds on to the tuple that is specified here. Okay, and then it does the same thing with the test path. Next, we are doing some pre-processing so that the image could be read by the model. So in this case, we are doing X train. We have NP zeros. We are using NumPy to do this processing. We are converting those image pixelations to zeros, and then we are passing it through the length of the train IDs, in entire length of the train IDs. We do an image height, image width, and image channels, and then we are assigning it a d type of integer. Okay, and for the y train we are assigning a d type of boolean. Now here this part is like ideally the most complicated part when it comes to any kind of ML problems, because this is where we are doing the pre-processing of the images. So what this is doing is this is resizing the images and the masks from the stage 1 train folder. So we have n, we are specifying the n, the IDs of the images in and we are using this TQDM library that basically shows the progress. We are enumerating, that is traversing through the entire set of training IDs, and then we are going until a total of the last training ID. Okay, then we have path. We define the train path along with the image IDs. Okay, and then using the IM read and the IM show, using the IM read, we are reading the images, and then we are passing the image channels as well. Okay, and then we are resizing the images with the height and width of the images. We are keeping the mode as constant, and we are preserving the range of the image as well. And then we are assigning the X train to this n. So therefore, this is the list and therefore this X train, after getting resized, is populating with all the resized images. Similarly, we are doing same thing with the masked images, where we have we are using np.zeros, we are using the image height and width, and this is just one. Why? Because we are not using all the channels. The reason being, I mean, this is a segmented. In the mask folder, we have segmented images, and we have d type of np boolean. Now we are iterating through all the mask files. We are walking through all the mask files, and we are doing this. We are doing similar kind of image transformations. We are expanding the dimensions. We are resizing it, and then passing it through an NP array. And then finally, this becomes our Y-train list. Y-train, and we are passing it through the masks. Okay. Next, we have the test images. So, okay. So now, in as I mentioned, in this stage 1 test folder, we just have the images which are pixelated images for prediction. So in this case, we will use a similar kind of method as we have used for the X train images, not the mask one, X train images, right? So we'll use similar things, and then we'll just append those images to the X test data frame. Okay, and then once this pre-processing is done, it just prints done. And you just know, by the way, when you're doing this pre-processing, so you will see a progress bar, that basically notifies you how far your pre-processing is there. And to ideally to run this UNet convolutions on this particular data set, if you do it on a CPU, it's time consuming, it takes a lot of time. I would suggest, if you want to, if you want to explore this, use just go to Google Colab, put this data, download these data sets into your My Drive, mount your My Drive to your Google Colab, and then use this notebook to run it on a GPU instance, on a GPU backend, and it should be faster. Okay, and here what we are doing is just we are printing a piece of code to just see the pre-processed image. So we have image X random randint, and then we are passing it through the length of from 0 to the length of the training IDs. We are asking it to show the image. Plot.show is showing us the image, and then we are also, we are doing the same thing for basically X train image and Y train image to see how the pre-processed image looks like. So post that, all we just need to do is just build the model. So this model code is something that we have described just while explaining UNet architectures, right? So in this case, we have the inputs, tf_length or input. We have the image height, width, and image channels. Then we are passing it through S. We are dividing this by 255 because we need a floating input. And then the contraction part, C1, 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 then P1, dropout layer, as we have mentioned, it starts from 16, it increases 32, 64, 128, and then we keep the padding layer as same. And then we finally go to the bottom layer, C5, and we apply this 256, and here we are just using a dropout layer of 0.3, which is 30%. And then we are moving on towards the upsampling path. Now post this, now we are going through upsampling path 6, we are concatenating it to C4, and that's how we are getting C6. Similarly for U7, concatenated it with C3, we are getting C7. U8 concatenated with C2, we are getting C8, and similarly for U9, we are getting the same. So this was explained a while back, right? And then we have the output of the UNet, which is TF_layer, which is a convolutional 2D Y1, because we need the output is a final convolution layer of 1 into 1, right? Okay, and then we are using sigmoid because again it's a multi-class classification. So now we pass it through the model, model. We take the inputs and the outputs. we compile the model using the loss optimizers, the loss and the metrics, and then we print out a model summary. Model summary basically prints out the architecture. So if you are familiar with other general keras algorithm, then in that case you would know how model summary works. So this prints out the model architecture. So while coding this, since this unit architecture is a little bit complex, always keep a note of what you're inputting, what is going for each of these layers, and what you're outputting. So always print out a model summary that helps you understand what's your model architecture at each of the convolution layers, right? And then we build a model checkpoint. Post we validate the architecture, we build a model checkpoint wherein we use callbacks, model checkpoint for nuclei H5, and we use a verbose of 1, then we just save the best only epoch. So let's say you have specified okay, I'll explain that while I explain early stopping. Anyway, so model checkpoint is basically, it saves the best checkpoint, best performance of the model. So let's say, again, your model is running for 100 epochs and it's performing the best at, let's say, 60. Then it immediately saves the model at that particular phase itself, because that's giving you the best output, right? Because it is okay to run your model through multiple epochs, but it is not okay to overfit your model, right? So in that case, it is not necessarily, even if you have assigned, let's say, 100 epochs, you don't necessarily need to keep running your model through 100 epochs if there is a chance of overfitting, right? Will we be able to code? Yeah, sure, why not? Okay, so Dr. Rajiv, could you just elaborate a question from where will we be able to code as in?
Yeah, my question is as far as this contents are on Python basically, how this code would be more elaborated or practiced on? That's the only question.
How this code will be more elaborated
Or practiced on to do more practice.
Yeah, that's what I said. So I at the very beginning of the session, I told you that I'll be covering. That is exactly why I have no slides, because I have
Yeah,
used all open blogs as well as open GitHub repos to
yeah,
walk you through the code. So your next job, even Taggle dataset is open. This is not proprietary, right? So your
right.
next step would be, like, I'll be sharing these links with Anupriya ma'am, and she can share it across to all of you.
Yeah,
Your next step would be is to pull up a Google Colab. You know how to use Google Colab, right?
yeah, definitely.
Yeah. So pull up a Google Colab.
Yes, ma'am. You can share. I will share it to them, ma'am.
Sure. So you can pull up a Google Colab, download, make an account in Kaggle, download the data set, right? Extract the data
Okay,
set, put it up on your Google Drive. You can also mount your drive to your Google Colab, or else you can also mount your local directory to your Google Colab. If are you familiar with the process?
yeah, of course,
Yeah.
definitely.
So
Got it,
in
got
that
it.
case, then of course, then I don't need to elaborate on that.
Right, right. Thank you.
So just copy the code on Colab, take this out,
Yeah,
right, and use the data
only
set
then. Yeah,
and run through each of the process. Like, basically, for the first step, if you want to know how this is working, okay, so you take in the input from the data set, right, and
yeah,
then you pass on this pre-processing layers, okay, and then you
right,
print done. You stop your execution there. See, see the process has been done, or else you can stop your execution until here. So what this will do is, this will pre-process the image. It will give you the progress that it has been executed, and then in that case, and then this chunk of code will give you the processed image output. At least one image output you'll get. So you'll
right.
see pre-processed image output, and then I just walked you through this unit layer,
Yeah,
right? You understand, and this is in reference to the architecture of the unit that we just discussed. This is a 2D unit, right? So
definitely.
once you build this, once you build this, pass it through the processed data. Okay, and
Okay.
then all of these are now this very point are just like engineering part of it, wherein we are, if we have to save a model, I believe model saving has been covered in your previous sessions, right?
Uh,
Model checkpoints. Well, if not, let me know.
Like,
I'll just give you a one-liner definition of what these are.
no, sure. Now
Okay.
I understood that. Thank you.
Yeah, no problem.
Yeah.
Okay.
Thank you.
So
Okay.
basically, model checkpoints is basically saving your model at its best performance. Then we are doing callbacks, like early stopping. Early stopping is, again, let's say, like you're asking your model to run for 100 epochs, but let's say your model is performing at 60th epoch the best. Then your model, while training, it automatically stops at 68th epoch and it does not go any further. Why? Because it has received the best possible results. But does it stop immediately at that? No. It checks 3 epochs from there on, 3 forward epochs. Like, let's say your model is performing best at 60, it checks the 61st, 62nd, and 63rd epoch, and then makes a comparison and then stops there. Okay, so then you are not using a compute like, massively, and your model is stopping exactly where you are getting the best performance. Okay, and then you have the TensorFlow Keras callbacks, you have the TensorFlow boards, tensor board. This gives you, so once you start the tensor board, and also this particular GitHub has 3 YouTube links attached to it, created by this person. So go through this. He has explained this in more depth. Okay, and then if you have any doubt, you can definitely refer his videos and understand further, right? So what's happening here is, you are just pulling up a TensorFlow tensor board, and you're seeing the accuracy and other sets of blogs. Accuracy, sorry, not blogs, accuracy as well as the loss function curves. It gives you the accuracy curves and the loss function curves. It gives you the model performance at each of the epochs that is running. Okay, then we are doing a model fit. X train, Y train. We are doing a validation split. We are using batch size of 16. We are running it through, let's say, 25 epochs. You can change this to 100 epochs and then use the callbacks as per necessary. Okay, and so this is the part where we are doing the model fit. And now this bit of code is where you're doing the prediction. So you have the predicted train, model predict X train. Then we have the int X train shape. You're just taking the you are just taking the X train for the, so you've split the data here, right? 10% of that. So 10% of the entire set. So you take those prediction, training prediction, validation prediction, and finally the prediction testing using X test. And then you type out an accuracy. So basically, when you're performing any kind of predictions, it will have a probability between 0 and 1, right? So what this piece of code is doing is, it's like anything that's having a probability of greater than 0.5, it's assigning the value 1. And this is as type np dot uint 8, which means that you are assigning the data type to be an integer 8 format. Similarly, you're doing the same for the validation as well as the test set as well. Okay, and then you perform some basic sanity checks. I mean, these are not mandatory, but it would be good if you could do that. It would just help you as a coder to be double sure that what you're performing on is exactly similar and it gives the desired output. Okay, so someone very nice. Okay, so yes, of course, I will be sharing the blog links alongside the GitHub link and the dataset link to Anupriya ma'am, and she shall be sharing with all of you post this session itself. Okay, so this concludes an example of 2D unit. I'll just briefly cover 3D unit architecture before closing of the session. I am already away from time. Anyway, so a 3D unit, basically it has a similar structure as a 2D unit, and it just uses 3 layers as shown in this official diagram. So there's a paper on 3D unit as well, paper on archive. Go ahead and read it, and also there's a paper on 2D unit on archive, and FCN on archive as well. Okay, so then each of these block uses basically batch normalizations after the convolutions. So after each of the convolution layer, it basically uses a batch normalizations. I think I have another blog post that talks about 3D unit a little bit in depth, and I think I'll pull that up just to show you. Yeah, so this is basically a review of the 3D unit paper. So the paper is called Dense Volumetric Segmentations from Sparse Segmentation. So here in this story, you have a 3D unit. In this basically, you have a 3D unit architecture reviewed. So this is essentially the architecture of 3D, and it's close. You see, looking from the architecture, you understand that it's quite similar to the original unit architecture, the 2D unit architecture. It comprises of an analysis path on the left and a synthesis path on the right. In the analysis path, each layer contains a 3 into 3 into 3 convolutions. In case of a 2D unit, it was a 3 into 3 convolution, and in case of a 3D unit, it's a 3 into 3 into 3 convolutions, each followed by ReLU. And then a 2 into 2 into 2 max pooling. So in case of a 2D unit, you had a 2 into 2 max pooling, and in case of a 3D unit, you have a 2 into 2 max pooling, 2 into 2 into 2 max pooling with strides of 2 in each dimensions. And in the synthesis part on the right hand side, each layer consists of an up convolutions of 2 into 2 into 2 by strides of 2 in each dimensions, followed by 2 3 into 3 into 3 convolutions, each followed by ReLU. Shortcut connections from layers of equal resolutions in the analysis path provide the essential high resolution features to the synthesis path. Okay, and in the last layer, again, like in the case of 2D unit, you have a 1 into 1 into 1 convolution, which reduces the number of output channels to the number of labels, which is 3. And batch normalization is used before ReLU, and a total of, I guess this is this yeah, one, I guess it is 190 million six, no, one, I'm losing the count, by the way. I think this is somewhat around 19, oh sorry, it's somewhere around 19 million parameters in total. This entire 3D unit has a total of 19 million parameters. While you do this, while I'm on this number of parameters, so once you use this code to print the model summary, check out the number of total parameters, not just the total trainable parameters, but the number of total parameters for 2D unit as well. I forgot the exact count, but it is also quite good number. Okay, and yeah, so this is all about 3D unit that caters to 3D images, more, and 2D unit caters to 2-dimensional images. Okay, so this precisely concludes my sessions. I will, as mentioned, I'll share the link of these blog posts as well as the GitHub on with Anupriya ma'am, but I can stay for another 5 minutes if you have any questions or if you have any discussions. If you would like to talk about today's session, and or else if you want to talk about the unit or the image segmentation process in general or anything else, if not, then I think I can conclude the session from my end. Hopefully all of you found this session helpful. And to be honest, image segmentations as well as instance segmentation is definitely a go-to use case and a very popular use case these days, and is being implemented in a lot of industrial use cases as well. And unit, the research community has evolved unit. There are various other flavors of unit. I'll just once again just quickly share my screen to tell you that okay, so this blog post, this one has various other unit flavors as well, like VNet, which is for 3D MRI volumes. Then you have unit plus, then no new net. This is also an architecture. and then a few more things here and there. So I'll of course share this link, read through this. And image segmentation specifically, I mean, it is very helpful in case of medical images, and simultaneously it has found profound use cases in other areas as well. Okay, with this I conclude my session. If anyone has anything to ask or say, or else I hand over to ma'am.
Thank you, ma'am.
Yeah, I would like to thank all
UNET and I know the relationship, yeah, the CNN and the participants, if you see in the chat window also, they have given very good feedback, ma'am. Like, you know, they feel that you have given them a practical exposure. And you know, onwards, I think they can build further. And kindly do share the GitHub link as well as the YouTube links which you mentioned, so that I can share it with the participants. Apart from that, the session was really valuable and informative, and we really thank you for your presence and your presentation, madam.
Thank you so much. And also I would
Thank
like
you
to
very
thank the
much.
participants for listening to me. And sure, I mean, I again, as I mentioned, I'll be sharing all these links of the GitHub and maybe a few more examples here and there. Someone asked, can unit be used with agricultural data set? Well, agricultural data set, if it's an image, like if you're using satellite imagery, you can. I think I came across an example. I'll just find that out and share it with ma'am, so that ma'am can share it with everyone else. Yeah, I am available on LinkedIn. So if you just search my name, Sukanya Mandal, you'll get me on LinkedIn.
Yeah, thank
so
you, ma'am.
much.
Thank you very much.
I'll just leave the session now. Yeah.
Thank you very much. I have few points to share. Please hold on. Thank you, madam. Thank you very much. Participants, I'm very happy that today also we are having attending this FDP, and many have given positive feedback. I'm happy about it. And I look forward to associate with all of you, you know, like even in future FDPs. Now, lunch session, like, see, there will be a small change in the schedule. So please be informed about it. Like, see, you know that 12 to 1, we have cutting edge, that is session 18, cutting edge research works in science and technology. Now, the professor is from IIT Delhi, and a very high profile professor. So he has requested both the sessions to be together. The purpose of that is he feels that wanted to keep the momentum, it should be meaningful. So what he suggested is he wanted to take the continuous session. So now the time is 11:40. Okay, so we will meet by 12 o'clock. Maybe you can have a short break. 12 o'clock to 2 o'clock, and the lunch will be from 2 to 3, because he has preponed his session and he wanted it to be together. The main purpose, the only objective is to keep the momentum of the whole session, and it must be meaningful. Lost. That's the only objective. So we will have a brunch and come back by 12 o'clock. We will start by 12 and it will go up to 2 o'clock. 2 to 3 will be the lunch break, followed by that 3 to 4. As I told you, we will be haven't completed the day 4 assessment. So all the links will be open. I'm making it very clear. All the links will be opened from day 1 to day 5. See, day 5 post lunch session, I mean to say the session which, so you will not be having assessment on that. But the pre-lunch session, which is started from 9:30 to 11:30 on UNET, that is, it went up to 11:40 on UNET, you will be having assessment will be open. You cannot take multiple attempts. If you have already attempted and submitted, you will not be able to take. Only the people who have not attempted will be able to take the assessment. So 3 to 4 p.m. will be the assessment. 4 to 15 minutes, and I want all the participants to be available, and I would like to hear from you your experience, so that we can, your inputs are very much important and valuable to us, so that we can improve our further thank you. I'll get back again by 12 p.m. But please make sure that all of you are coming back on time. Please do not drag the time. We will be wasting our time. So please be on time by 2 o'clock to the session. Already, make sure you give the feedback. And another thing is, all the links will be open from 3 to 4. Whoever has not attempted can complete the assessment. Okay. So with this, I will close the morning session. We will meet again by 12 o'clock. If you have any concerns, please, we will address those concerns. Thank you very much.
for this introduction. Hope you can hear me. Am I audible to all of you?
Yes, sir, you are quite audible.
Yes, sir.
Okay. So please let me know if by chance if I'm disconnected or if I'm not audible. And I would like to request the organizer to give me a call by chance if I'm disconnected from my talk. First of all, let me check whether my slides are
Sure,
moving
sir.
or not. So please tell me whether you can see the change of my slide or not.
Yes,
Changing?
sir. We are able to. We are able to see.
Okay, very good. So the first part of my talk is cutting edge research in science and engineering or technology. And the second part of my talk, I'll talk about how you can write grant proposal to any government of India funding agency or maybe international funding agency or some other private agency. So before that, I would like to say good morning to all of you and to all the faculty members of KL University, as well as some other colleges, those who are attending my talk, and as well as the students and researchers are interested in this domain. So coming back to the title, Cutting Edge Research in Science and Technology, first of all, we need to understand why we all are doing science and technology or why we are interested in science, engineering, and technology. Um, so maybe if I'll ask this question to all of you, I might get some answer. Some people will tell that we want to innovate something or discover something, or we wish to develop some new things. I'll get n number of answer from all of you. Uh, Even some maybe student might say that we are doing science and engineering because people do pursue engineering. Most probably we can get good job where you can get the salary. So maybe I'll get n number of answer from all of you. But if I'll take the answer and let's say if I'll classify or if I'll try to make groups of all the answer, whatever I'll get from the participants, maybe I can make them two bins. Two bins means based on the response what I'll get. So only two things you will get, that why you are doing science and engineering. So first thing is we do science and engineering to improve quality of life, and the second one is quality of life means whatever you say, the innovation, money making, whatever you say, these are all related to improve the quality of the life. The second one is to understand the mysterious universe or the mystery of this universe, right? And that's why we all are doing science and engineering for these two reasons. So you just think, if you'll ask yourself this question, whatever answer you'll get, either it will go to the previous one, the quality of the life, or it will come to this domain to understand the beauty of this universe. You will not get the third one. And if please, I mean, if any one of you will get the third one, third bean, please let me know. Then I'll update my understanding. Okay. So the question is, let's say, I mean, okay, when we're talking about the mystery of this universe, you know, there are many mysteries in this universe are there, and until now, until today, we have very limited understanding of all those things. Let's say if I'll give an example, let's say if you can see my video, I'm showing you my finger, right? You can see my 5 fingers, and you see all the fingers are not having the similar length, and it's a giving very interesting structure, right? Just imagine if my thumb will continuously grow, then what will happen? If my middle finger would be shorter, then what will happen? Then it will definitely look ugly, right? And maybe will tell that this is one kind of disability or some kind of problem, right? So the question is, who is governing all this mechanism? Just imagine one day we are a single cell, and from that cell, from that zygote, I mean, the cell divided again and again, and from the same cell, some cell became our eye, some cell became our brain, some cell became our nose. The question is, who is deciding which cell will do this job? So this is one of the mystery I just told you, just related to you. But there are n number of mysteries. Even if you spend your whole life, still you cannot solve even one or two mystery. Just imagine how big this mysterious universe is. So that's why we do science and engineering. So here, let me highlight you some of the most important engineering problem. So if I'll ask you, just tell me which are the most fascinating area you see around you, or which are the area you feel that if you will be good in those area, you can do wonders, or maybe you can do good research, or you can get a good job. So what are the areas nowadays, cutting edge area? Can you tell some of this area? I'm asking to all participants. Maybe the coordinator can unmute them and some of you can answer that which are the most
First of,
sophisticated area nowadays.
yes, sir. First
Computer
of
vision,
all,
sir. Computer
AI,
vision, sir.
Okay.
artificial intelligence,
Complete
Yes, computer vision, artificial intelligence, and
machine learning, deep
machine
learning.
learning.
AR and VR, sir.
AR, VR, very good. Tell. Any other? Hello.
IoT, sir.
You know. Huh?
IoT.
IoT, very good. Next.
communication. It's the communication background of all the things.
Okay, communication. Okay. Anything else?
Smart farming. Mechatronics.
Mechatronics, very good.
Smart farming.
Smart farming, very good. Okay. Actually, when I'm talking to you, I don't see the chat. So better you please pick up. When I'm asking you, just pick up because I don't get a chance to see my chat because my whole window is covered with the presentation. Okay, very good. At least I got some answer. Okay, let me ask you another question to all of you. Which are the challenges in the healthcare or in the about the health related stuff? Which are the more bigger problem or not challenges? Let's talk about the bigger problem. हेल्थ में सबसे बड़ा प्रॉब्लम क्या है हेल्थ साइड में
Monitoring of continuous health problems, like
no
if
that's not
we are
I'm asking the health related problem means which are the most devastating problem. Devastating means diseases or something you feel these are really devastating and we need to find out some solution for.
cancer,
Sir, heart diagnosis. For cardiologist, heart attack.
cancer,
Heart attack, cancer, yes, very good, please speak up.
Precise
Anything
medicine.
else?
Precise
Huh?
medicine. Precise medicines.
Okay, you are talking about the precision medicine. Okay. Anything else?
Surgery, sir. Surgery.
Surgery, okay. Anything else? Okay, now you can mute yourself. Please listen carefully. Whatever I'm telling, maybe from there you will get many problems for your research. Please remember, when I'm talking about quality of life, what does it mean? See, whatever we are doing in engineering, that's for ourselves. We humans are very selfish in nature. If somebody will tell that I'm not selfish, then it means that maybe he is not a human being, or maybe he is not normal person, right? So the core principle of human being is one is selfishness, right? We are selfish. That means we always think for ourselves. We always think for ourselves means the first thing will come your health. Let's say you created a very big technology which can make your life beautiful. But just imagine if you are not well, will you enjoy that technology? Just imagine you are suffering with very severe fever, and I'll come to you and I'll ask you, let's go for a very good dinner to a very top, 7-star hotel. We'll have a dinner over there. Let's go there. What you'll tell? Ki nahi, no, I cannot go. I'm not well or I'm not feeling good, right? So the first, that's why always health. That's why you know that from our childhood, health is wealth. So first of all, whatever we do, first of all, we need to make ourselves healthy, right? Then only whatever the technology will develop, will enjoy, or if will earn, or whatever the money will earn, just doing science and engineering also will enjoy. That's why I've written here, quality of the life. How we can improve the quality of the life. So yes, very good. In the engineering domain, you coined few of this cutting edge research, cutting edge technology. Definitely, AI the hot cake nowadays. AI, machine learning, data science, robotics, IoT, mechatronics, computer vision. Already you mentioned all this kind of hottest area, right? And behind all this area, let's say whatever technology you talked about today, and you answered, people see that okay. Let's say people ask you, if I want to uh, bring a common thread out of all this technology, what would be the thread? What would be that thread? Do you know? Yeah, whatever the technology you told me, the cutting edge research, do you know what is the what is the one common thing in all this technology?
It's a, sir, we can say IoT. It's I mean, combined communication, hardware, as well as the latest ML
No, no,
DL
no.
based software.
Madam, I'm not asking this question. I'm asking ki whatever the communication engineering or IoT, all this, whatever you're telling, behind all this technology, there is a common thread. So let's say if I want to bind them in a common thread, what is that? I
Innovation.
want single word, single word.
Innovation.
Comfortable life.
No,
It's innovation.
no. Intelligence, intelligence. So everywhere, whether this computer vision, whether it's the IoT, whether this is ML, everywhere, all this technology are related to only one word called the intelligence. And this is where the world is moving. Are you agree with me?
Yes, sir.
IoT is nothing but, see, IoT is nothing but an embedded technology, right? So what we are doing, we are bringing all this individual embedded technology to a network, and where all this individual technology will talk to each other through this network. And this is what we are calling that we are giving some kind of intelligence to this, right? So the beauty of all this technology is intelligence. So I hope that you agree with me. So if you will take all this hottest area, again, the things will come that intelligence, right? Just like here, let's see what are the intelligence over here. I've written smart health, humanoid robot, smart car, smartphone, digital security, e-capsule, smart home. All these are cutting edge technology. You know that now the hottest area is the autonomous vehicle. That how we can, and already Tesla and many other company already started selling this kind of car. But the question is how we can make them intelligent, right? Autonomous means there is no driver. You have to tell the car where you need to go, and it will take you without driving. You know, humanoid robot. Now, in many restaurants, even the robots are working. They are serving the food. They are taking your order. And you must have already heard the term called the Industry 4.0. Industry 4.0 is again the automation. And this is the age of Industry 4.0, where you know that the robot is going to take care of many things. But at the same time, don't think that when this robot will take care of all these things, then human will lose jobs. Not at all. This is not at all a true statement. Even if the robot will come to the picture, but still it will create enough job for the engineers. But only we need the people those who have right kind of expertise, right? Humanoid robot means, I mean, you know that the robot will do very traditional kind of job with much more efficiency. So in Industry 4.0, the main idea is to increase the productivity, to increase the quality, and all this thing can be done by machine only. Why? Because the true difference between a human and a machine is, you know that human are intelligent, right? Compared to the machine. But where human is inferior to machine is, human can easily get tired, whereas machine, they don't get tired. That's why due to this tiring kind of things, and also another thing is that human can easily get bored, whereas the machine, they don't get bored. So if I'll ask you, in an industry setting, please stand at this location and see that how this machine is working, or whether any wear and tear is happening in that part. So if I'll ask you, maybe after some time you lose your interest. Who will do this job? Just standing and doing this job. And then the productivity of the industry will not come up with this, required goal, right? That's why the think tank thought that we should give this job to the machine or the robot. And that's why this Industry 4.0 has come up. So in all places, in all kind of industry, now we are giving some kind of artificially created intelligence which will monitor everything, right? If we talk about digital security, you know there are many different ways we put the security, whether the face recognition, whether this is iris recognition, whether this is fingerprint recognition, all everywhere we need intelligence. People talk about the e-capsule. E-capsule is nothing but a pill. If you take this pill, it has 360-degree camera, and when it will pass through your alimentary canal, it will send the picture. At the same time, it will send the picture to the doctor, and the doctor, through the different kind of analysis software or just image processing tools, they can see that where you have problem in your alimentary canal. And if we talk about the smart home, I'm telling you that if you are interested in this area, please, I mean, whatever here I mentioned, I mean, I just mentioned 3, 4, 5 area, but these are all hottest area, and there are many areas are there where if you will invest your energy or your time, you can be the winner one day. Let's say smart home, that India has the huge amount of old population and going to have the huge amount of old population, but we don't have the right kind of technology. So can we create the smart home kind of concept? So where the technology can look after your parents or the old people, and they can alert the doctor, they can alert the caregiver, or they can alert their relatives. And in that way, we can solve a very big problem which our country is going to face, right? So here I'm given the example that how you can do that. See, here, whatever I'm telling you, I'm not going to tell you, I'm not going to show you many mathematical equations or all this stuff. I'm going to give you the concept. Please try to understand the concept. If you can understand the concept, you can do everything, right? So here, let's talk about this autonomous vehicle. Autonomous vehicle, as I mentioned to you, this is one of the hottest area nowadays. And if you have expertise, then sky the limit. So here we are giving knowledge to our driver how to drive on the street, right? No, not driver, I mean the machine. So just imagine when you are driving your car, and let's say in the street like India, where it's very crowded, if you're driving, then just think how you take very judicious decision when some pedestrians will cross, or if you are on the very close to the cross point, let's say red light point, then how you take the decision. Just imagine that you are about to approach a red light, and there are, let's say, 100 vehicles in front of you, and you can see the timer which is started the counting down 30, 29, 28, 27 like this, and now only 10 seconds are there. And if you, I mean, when you're driving, you can see that only 100 vehicles are in front of you. What you do? So what you do that you just try to estimate that whether with my this speed, whether I can cross this red light or not, right? And just imagine what kind of decision you take that time. And this is what is called the real intelligence. And can we create the model just like the human thinks when they try to approach this red light? Can we take this kind of decision, and can we create a mathematical model out of it and give to this machine, so that machine will also do the similar kind of job like human? Is it possible? Let me give you another scenario. In Indian roads, when you drive, in many times you must have observed that many people also drive on the wrong way, right? But still, you don't collide, right? But do you think that if this will happen with this autonomous vehicle, they will not collide? They will definitely make an accident. So the question comes, when you are driving, you are not doing this kind of job, then why they are prone to do commit the mistake? So these are the questions still not answered. So now definitely you will ask me, then how come then this autonomous vehicle is possible? How in people in US or Europe they are driving it? Yes, in US and Europe, mostly everything is rule based. They follow the rules properly. And when something is rule based, that time the machine will do very well. But when it's the some kind of situation like our chaotic situation in India, you must have seen in many crossroad, even our traffic police they don't work, even our traffic light that doesn't work. This still people can manage very well. This is the true intelligence. Can we give this kind of intelligence to the machine, and then most probably it can do its job uh, in the right way. So this is one example. I hope that you got the idea what I wanted to give you. Second is, let's say, face recognition. Face recognition, again, this is a very interesting computer vision problem. But here, let me tell you one thing. If you search in the Google about the face recognition, you will get hundreds, thousands of paper, right? But the question is, why still we are doing research on this face recognition? What's the lacuna here? And I'm telling you, face recognition is still a multi-billion-dollar problem. Why? Because face recognition is applicable in any places, surveillance, security, wherever you will see. Just imagine, I'm giving a very real kind scenario. Maybe you can take up this kind of research. Let's say when generally in our Indian hospital scenario, it's very crowded. And also, that when somebody is having very, let's say, one kind of fatal kind of situation, when you go to the hospital, it takes time to fill the form and then find the right doctor, right? And then to get the treatment. And during this, due to this delay, many life also, I mean, we have to lose many important lives, right? So the question is, let's say I'm ill, and when I'm entering to the hospital, the camera will recognize who am I, and automatically, in the same time, using some intelligence, it will try to find out the files related to my name. If I have some kind of problems earlier, okay, and in the same time, it will try to find out who is the best doctor in the hospital or who is available at the time, so that it will directly connect to me. So when I'll enter, I need not to do all this paperwork. Automatically, it will be done by this intelligence. I mean, artificial intelligence, and I can directly go to the doctor, or I can get the care without losing any important times. Can you do this? So this is one problem I mentioned, but here in terms of facial recognition, what is the challenge? So I'm telling you the idea over here. Let's say, if I'll show you two pictures. One is Rajanikanth, your South Indian, the hero Rajanikanth, right? And another random person picture, if I'll show you, definitely you will be very excited to see Rajanikanth's picture, right? But both the images are, let's say, Rajinikanth's face image or somebody face image, or both are face image. But my question is, why you are excited to see the Rajinikanth's image? Why not the other person face? Because face always contains two eye, one nose, two ear. Both are same in this two person. Then how brain is differentiating these two people? And how come we can recognize somebody's identity? So these are all very important questions still we don't understand. And when we don't understand, we cannot mimic this kind of model in the machine, right? Here, let me give another example. Here I've written multimodal information linkage. What does it mean? Multimodal information linkage means, this is a very interesting concept. Please try to understand this concept. So let's say you are standing, right? And I'll come and I'll give you a mobile phone to touch. I'll tell you, show me your hand. Don't look at what I'm giving to you. And I'll give you a mobile phone to touch. And I'll ask you, please tell me what I've given you to touch. You can easily tell, though you have not seen what I've given, but just exploring by your hand, you can know, oh, maybe this is a mobile phone. And when you are telling me this is a mobile phone, the same time, though you have not seen it, but you can visualize it, right? Just imagine another scenario. Let's say in the evening, your very close friend called you from US. Let's say your close friend is right now in US, and he gave you a call. And when you are talking to your friend and you can hear your friend's voice, but at the same time, you can visualize how your friend look like, right? And this is called a cross model mapping. That means you are mapping from auditory information to the visual space, right? Just like here in this robot, you can see, though the robot is holding the mobile phone, but that's why I gave this example, that from the tactile information, you are converting to the visual space. So here the big question is, do we understand this mapping, this mechanism of mapping, that how as a human being we do this? And if we can understand this mechanism, we can give to this machine. So until now, no machine can have this kind of ability. And I'm telling you here, we are intelligent because our all sensory modalities, they crosstalk to each other. And they do in such a remarkable way, which we don't understand how it's happening, right? Let me give you another example. Here, I've written who is intelligent. Here in the left side, Cherry. Cherry is just 2 years old baby. And the right side, you can find Sophia. Sophia is just, the most sophisticated robot in this world, right? So people ask you, who is more intelligent? 2 years old Cherry or the most sophisticated robot in this world? What would be your answer? Hello, I'm asking you. Anybody can unmute and tell me who is more intelligent, Cherry or Sophia?
Naturally, Cherry.
Why you think so? Because Sophia is the most sophisticated robot. Sophia can do everything.
But it's a man-made. Whatever intelligence we give her, that is the only limitation for Sophia. But
Okay.
the
So here, madam,
No.
you have used your intelligence, right? That's why you can tell Cherry is more intelligent, right? If I'm asking, definitely must be there something. Very good, madam. Okay, let me show you these two video. Just see these two videos. I hope you understood what I wanted to show you. So here I just showing you that this baby just who is climbing the stair, just 2 years old baby, right? And the robot here I'm showing you. Am I audible to all of you? Am I audible?
Yes, yes.
Okay. So here the robot which you have seen in this video, this is one of the intelligent robot. So here the main difference is the child who is climbing the stair. Maybe when the child started climbing the stair, maybe the first day, or when the child tried first 2 3 instances, she might fall down, right? But after maybe 10 instances, she could climb easily the stair. Whereas this robot is being trained with millions of examples. In the machine learning, we trained with some kind of examples, right? We call the training data set. Likewise, this robot is also trained that how to climb millions of time. But after that also, the robot is falling down. So here, this is a big question: that how come a child just after doing 2 mistake or 3 mistake can do this job perfectly, whereas the machine cannot do this job perfectly? So this is the difference between true intelligence and one sort of restricted intelligence. So that's why I mentioned here that also Madam told that Cherry is much more intelligent than Sophia because of this reason, and this is one of the mystery we need to understand, right? Um, so here I'm giving another example. You can see here in this picture, Barack Obama is shaking hand with this person who is sitting on the wheelchair, and his hand is actually he's paralyzed. He cannot control his hand. So he has this is a prosthetic hand, electronics hand you can see, and he can control this electronic hand but by using this brain signal. Though the person has no hand to shake, but using this prosthesis, he can shake hand with Barack Obama, and this is coming into the domain of neural prosthesis. So these are all hottest area nowadays. So earlier you must have heard that many people work on this lower limb prosthesis or upper limb prosthesis, and those are mechanical prosthesis, and mostly they are all muscle signal control. But now scientists are working with the neural signal control, and which would be much more accurate, right? So likewise here I'm giving another example. Um, so here it's very also interesting. Here this person who is wearing this glass, he's a blind person, right? And the person who is standing behind him, red color guy, he's the scientist who developed this prosthetic eye or prosthetic or no, computer vision technique to help the blind to see. And here the person is telling that I am very happy, this blind person, ki first time I can see my wife clearly. But actually, here the truth is something different. The person cannot see his wife completely clearly. Only he can see some dark and white patches or some kind of contour, not the clear picture the way we see. So the question comes that why this person is not able to see his wife clearly, right? So these are the challenges. So why this is a very big challenge? Okay, I just forgot to put a picture here. So this is a very interesting problem in computer vision. So in the computer vision, always what we do, whether it's object detection or any kind of problems, what we do in our everyday lives. So we try to mimic the human vision or human visual system to implement in the machine. And this is what we call the computer vision. That means the way humans see or human recognize, if we can give this kind of knowledge to the machine, we call this a computer vision kind of applications, right? But the question is, last more than 20, 30 years, many world leading university, they are working on to create this kind of processes, but why they are not successful? Because until now, our knowledge is very limited in understanding how our brain process all this information. Let me give one example. You can see here, in my hand, I have a pen and one mobile phone. I hope you can see in my video. So when I'm showing you these two objects, people think about physics. What is happening? The rays of light is entering into your eyes, and then after that, your brain is able to tell, oh, this is a pen and this is a mobile phone. But have you ever thought that how this range of light, the range of light is same for pen and mobile phone, but how come it is organizing all this beautiful orchestra in our brain, which is helping us to recognize this is a pen or this is a mobile phone? How it's doing? This is one scenario. Let me give another scenario. Just think, if when I'm showing this two object to all of you, and maybe some of you cannot see that I'm holding two object. What does it mean? Did you get my question? So in one instances, I told you that you can see the pen and mobile phone. Maybe in this crowd,
हाँ
let's say
संजय बेटा वो आया क्या स्मिथ के आदमी?
what?
हाँ थैंक यू मैं उससे बात करता हूँ अभी बेटा बोलता हूँ कहाँ पहुंचा है नहीं तो अपने को दिक्कत हो जाएगी बेटा ना
Are you asking me some question?
So I think there is someone has unmuted, sir. I have muted all. Continue, sir.
Okay, okay.
By
That's
mistake,
fine.
by mistake.
This is the problem in the online talk, right? Okay, that's fine. So when I'm showing you this two object, I'm just telling you very interesting concept. Please try to understand. Now you can see that one is pen, one is mobile phone, right? But let's say 100 people are attending my talk, and when I'm showing these two objects, maybe some of you cannot see that what I'm telling. Then he will tell, Ki, oh sir, whatever you are showing, I mean, you are telling that you are showing some mobile phone and pen, but we cannot see anything. This is also possible, right? That's why one famous scientist, physicist, he told that working in this physics last 50 years, he's a Nobel, I forgot the name, that I believe nothing exists in this world. And I am completely agree with his statement. Nothing exists in this world. What you see around you, these are, I mean, nothing is exist. But at the same time, I can give the statement, yes, everything exists. And how we are able to tell this something is exist or something does not exist, it because how our eye or how our all the sensory modality and the brain, they are creating this kind of orchestra, they are doing the magic for us, right? So you must have seen Tare Zameen Par. Tare Zameen Par, the child artist, he is telling that जो होता है वो दिखता नहीं है, जो दिखता है वो होता नहीं है. It means that, I mean, what exists, okay, you cannot see, and sometimes you can see which does not exist, and this is very true. And the similar kind of concept I'm trying to bring to over here, when the rays of light is entering to our eyes, okay, and when it is passing through different pathways from eye to different, I mean, lateral geniculate nucleus, optical path, and then reaches to the brain, and if the things are not getting encoded properly in this whole pathway, then you might not see anything, right? And when somebody tells that I cannot see anything, then हम ये सोचते हैं, we think that maybe that person is mad or there is some problem with that person, right? And this is true. So that's why it's very important to understand how, when the rays is entering to our eye, how it being processed in each and every step of this pathway. And this is not until understood. Nobody has answered this question. Even nobody knows that how this is happening. That's why we are not able to develop the right kind of visual prosthesis for the blind. I hope you understood this concept. Okay. So likewise, here I'm showing you another very fascinating terminology called the deep neural network. You all are fascinated about this, and I mean, we all feel that when somebody tells that I know deep neural network, we feel that, oh my God, he knows artificial intelligence, right? But sometimes I feel that even when I ask in many different platforms, when I deliver my talk, when I ask how many of you know deep neural network, then I see 90% people show their hand, sir, we are expert in this area. That time I feel, is it true? But then I feel that then I tell, okay, though I'm talking all the subject, but even I don't know all this kind of area. Even I feel that I'm a learner in this area. So deep neural network. So actually, this is a very fascinating term to all of us, right? But here I'm just posing a challenge to all of you. Let's say if I'll give a problem to you and I'll ask you, tell me, for this classification or for this learning, how many layers I should take for my DNN? Can you tell the answer? Can you give this right answer? And I bet you nobody can give you this right answer. Why? You just go to whom you feel that the expert in this domain, you just go to him or her and ask this question today. Because why will not get the right answer? Because there are many things we don't know how it's happening. And you'll be surprised to know that scientists are very clever. That's why they've given the name deep neural network. You never know how deep it is, right? Whether this is 100 feet deep or 200 feet or 500 feet, nobody knows. Okay. So why we don't know? Because we don't know in human brain how things actually get processed. Now, as the people try to understand that how the brain does all this remarkable job, and they found key, okay, this is the way it works, and they came up with this idea. And yes, I mean, it is working very well. Deep neural network is working very well, but actually, this is a very static kind of network. But I believe I'm telling you on this platform, take my word, I believe that this network would be obsolete from the market very soon. And again, some kind of dynamic network will come. Why? Because that picture also, you let me see if I have that picture. I don't have that picture. No, I don't have that picture. Okay, here I missed that picture. So the brain is very dynamic in nature. Each and every fraction of second, the neuron changes their connection, and through this kind of mechanism, they create all this interesting orchestra in our life. That's why, that's why our intelligence is something superior to all this. I mean, this artificially created intelligence, right? Uh, so when I was talking about all these engineering problems, so these are few, but there are many. So as I told you, IoT, computer vision, robotics, everywhere you will see the intelligence, right? In the same time, when I was asking you, what are the big problems in health? And though you gave some answer, though I'm agree with you, but in the same time, I'm not completely agree with you. The most biggest problem in the healthcare is not COVID, not diabetic, not cancer, all problems related to the neuron. This is called the neurodevelopmental problems. These are the real problems, right? And here, the scientists are working many decades, but they are not able to understand why this is happening. At least there is solution for the cancer, there is solution for the diabetics, there is solution for the heart disease, but there is no solution for any kind of neurodevelopmental disorder like Alzheimer's, Parkinson's, autism, epilepsy. These are all devastating problems. You will be surprised to know 1 out of 17 Indians are affected with autism, right? 1 in 100 Indians are blind. These are all very big problems. But that's why here I'm showing you, you can see the autism. Autism is called the autism, this is ASD, autism spectrum disorder. In some children, they have language deficiencies, some children, motor skill, some children, visual skill. So all different kind of problems they have. But the question is, do you have the solution for it? Until now, there is no medical solution. When you go to any clinic, the medicine the doctor will prescribe, these are not the direct medicine to treat this kind of problem, but to suppress some of the underlying mechanism of this problem. So the question is, do we understand? Can we come up with the solution for this kind of problem? So likewise, I told the epilepsy. Epilepsy is also a big problem. Not only the diagnosis, but also can we predict or can we find out the prognosis of this kind of problem? And the solution is in your hand, being an engineer, right? So likewise, there are many interesting stuff is there. So here I've written rewriting, reformatting. That means you know the rewriting, reformatting in your computer domain. We format, we rewrite. But can we do? Can we understand this principle in the brain? And this domain is called the brain plasticity. So whether the brain is plastic, whether you can change the function of the brain from one place to another place. Let's say if somebody is born paralytic and he is not able to move his hand or leg, so can we give this function to the other part of the brain so that the brain can control? So looking at all this kind of problem, so I'm not discussing here. Okay, looking at all this kind of problem, it looks like you need to understand the right kind of intelligence. As I told you, whatever, whether it's in engineering or medicine, through these examples I gave you, I convinced you that there is a one term connected to all this kind of things called the intelligence, and this intelligence is in our brain, right? Intelligence of our brain. That's why in 2012, when Barack Obama was the ex-president of USA, he announced that the world should take very sophisticated research to understand the brain, right? Why? Because if we can understand the intelligence of the brain, we can take the lead in all these sophisticated engineering domains, whether this is IoT, whether this is the cognitive computing, whether this is artificial intelligence, machine learning, because all these are related to the human brain. At the same time, if we look at the health, as I mentioned to you, in the healthcare domain also, all these big challenges lies with the brain or the neuron. That's why, and all this problem, what I mentioned to you, these are all big problems, and there are lots of opportunity in all this problem, and you can take up all this kind of problem, right? So I talked about that why you do science and engineering, and then again, the first part was to improve the quality of the life. The second part was the mystery. What are the mystery? I'm just showing you some of the mystery. You can see what you see in this picture. The wheels are moving or static? Can anyone tell? The wheels are moving or static? Hello, can you hear me?
Yes, sir. Although it's a static, but perception,
Wheels are moving or static? Don't apply your intelligence. Just tell me what you see.
Moving, sir, moving.
If somebody is seeing static, please go and check your eyesight. It looks all are moving, but the truth is these are not moving, right? These are all static, but actually it looks like it's moving. Okay. Can you just pick this black spot? Okay, just can you track the black spot, how it's jumping? Can you see the jumping black spot or it's static? You can see some black dots are jumping, right? But the truth is, it's not at all jumping. So see, that's why I told you, what we see, it does not exist, and what it exists, we sometimes we cannot see, right? Okay, now in this picture, can you tell me which one is brighter, the inside one or outside one? Outside, where I'm moving my cursor, you can see. This is brighter or the inside brighter?
Outside, sir.
This part or this part? Brighter. This is inside and this is outside. Which is brighter? Which looks brighter? So in this slide, the brighter is the inside one looks brighter. Okay. The lines you can see on the slide, whether they're parallel or not parallel, how it looks to you. It does not look like they're parallel, right?
Sir, not parallel.
But in reality, they're parallel. They're all parallel lines. Okay, you can see here, you can see this heart kind of symbol, right? So the cursor where I'm moving, if I take a small voxel or pixel of this heart and the right heart, whether the color are same or different, definitely it looks like different color, but actually they are same color. Okay, so another picture. Okay, here in this picture, please see my pointer. So this color and this color, they are same or different? It looks different, right? But actually they are the same color, right? So likewise, there are many, I mean, I just gave some examples from the illusion side. These are called the visual illusion. And all this visual illusion, the scientists know few of the answer, but we don't know many of the answer. That's why what exists, it does not look the same to us. Why it does not look same to us? So these are some of the mystery I told you. So there are many mysteries in this world which we don't know that why it's happening. And for these two reasons, to make our life beautiful or to improve the quality of the life and to understand this mystery of this universe, we do science and engineering. I hope you understood. And in this way, I mean, if we can take up all this problem, definitely the sky is the limit, right? That's why here I'm just showing you that that's why you need to first look at the intelligence of this brain, human brain. And if you can understand the intelligence of this brain, and then you can do, or you can, the sky the limit to advance the domain of engineering and the different branches, whether it's the communication, whether this is AI, whether this is robotics, you can take the lead, all this kind of domain. So some of this research is happening in my lab. I mean, we work at the interface of both artificial intelligence and natural intelligence. We work on the human brain. In the same time, we try to mimic all this intelligence in the machine to create many AI systems, right? One of the, okay, let me give you one example of what we do. Okay, just one. Okay, I'm not talking about all this big thing. Maybe let me see. Oh, the video is not working. Okay. So I hope you understood, and maybe in some other avenue, if I'll get a chance, some other avenue, I'll show you some other interesting work what we do in our lab. This is about the first part, and if you have any questions, please ask me. Otherwise, I'll start talking about how you can write a good research proposal, right? And now your time. You can ask me questions. Hello.
Participants, if you have any doubts, please you can ask. Actually, most of the questions you're answering then and there, no, sir. So I think
Okay.
not much questions
No
at the
question.
end.
So
Anyhow,
I'll believe that
I'll
Syed, I
ask
mean,
them
okay.
again. Yeah.
Maybe they understood everything, or maybe they could not follow my talk. Either of this.
No, sir. No, sir. We understand all the things. You have given
No,
a
sir.
very,
Now and then we were
very
having
excellent
answers.
presentation.
I think definitely they are following. It's quite interesting also.
Yes, sir.
Okay.
So definitely they are listening.
Okay. Thank you very much. Yeah. So I just gave you very big picture to all of you. So I didn't showcase the research. I mean, what we are doing. So okay, definitely. I mean, you'll get many other opportunity. So in the same time, also I can announce one thing. Every year March, I organize one workshop for the faculty members from all over India, and about the brain mapping and artificial intelligence. And this is one kind of, I mean, one kind of uh, this is basically I try to train the people in India in this kind of domain. So mostly I do offline. Offline means the participants come to IIT Delhi and stay here with us for 5 to 6 days and learn the things and do some hands-on. And these are covered by the government of India, all these expenses. So and also last 2 years we are doing online mode because of this COVID. So this year we are not sure, but definitely it will happen either in the offline or online. If anybody is interested, can join that workshop. That's one of the best workshop I can say in India. So I mean, we have not advertised yet, but in a month, if you will search brain mapping and artificial intelligence, or in my website, you can find the information. So if any one of you is interested to learn more about those things, okay. So then coming to the second part of my talk, research proposal drafting. So first of all, let me ask you that how many of you have already taken some projects from Government of India or already pursuing some kind of projects? And also I would like to know that how many of you are planning to apply different kind of fundings? Or in the same time also I would like to ask you, please note down your queries, that what you need to know. Definitely I'll talk general things, what I know. being the member in all the expert committee of Government of India, whether DST, SCRB, DBT, or the MIT. So in many committee, I am one of the members. So I know that what the Government of India looking for. And sometimes I feel I also propose to Government of India, not me or many other expert members who propose that we need to have this kind of training session to the people when they are about to submit a proposal. What are the things we look at, and based on which we select or we reject, right? That I'll discuss. But before that, please tell me if, I mean, how many of you here have already sponsored project from any Government of India funding agency, or I mean projects more than, let's say, 10 lakhs rupees minimum. So anyone has any kind of projects?
I have received a small project, TechU project, which is funded by the government. It's a RGPV university in MP. So
Okay.
they funded a small project of 3 lakhs only, not
Okay.
more than
Okay.
10
So
lakhs.
you have not submitted any big grant proposal, right?
We submitted in DST, but
Ah.
unfortunately we didn't get it.
Okay. So how many of you are planning to submit any grant? Okay, if you can tell me, okay, I'm planning for power grant, or if somebody will tell, okay, I'm planning for TARET or TARE
We
grant, or some.
submitted, actually we submitted in DST a product to, that is project to product.
Okay, I got it.
Under the category.
Technology Development
Yeah,
Board.
yeah.
Right. Right. Okay, any other question? Okay, just tell me some of the questions, I mean, which you would like to know, so that accordingly I'll tell you.
So we have tried for research proposal, sir. We tried,
Correct.
but
Which
unfortunately we
one?
didn't get any amount.
Which one? CRG, SRG? Which one?
Sub SRG.
CRG.
Sub
Okay.
proposal.
No, SAR proposal in SAR SCRB there are many
Research
different
grant, sir.
no, research grant actually, core research grant, yeah, special research grant, or Supra. These are the different name.
Core research grant, sir.
Core research grant. Okay. That I'll tell. Any other questions?
Sir, we would like to apply for the power grant, sir, women power
Yes,
grant. I
this
think
is a very good grant for the women.
many, actually, some of our faculty members, around 6 DST projects we have submitted, sir. It is in the third stage, but still we didn't get, we are awaiting the results actually. We have a few questions, like number one is, how, first of all, like from idea to actually funding, most of the time we fail, like though we have idea, projecting it in the right, and second one is budgeting. In budgeting there are some differences, and like how the government is looking for, and what kind of priorities we actually have to look for. So these things, if you can address, it will be really helpful, sir. And most of the participants are doctorates, as well as we are having mixed participants actually. And there are many women also. So it would be really grateful if you can touch on these aspects.
Okay, very good. See, one thing I can tell, now the Government of India has very good program for the women, because they want to bring women to the frontier side of this research and all this technology. And one of them is the power grant, and power is really good grant. So in almost all this committee, see whether it's the power, whether it's the and also for the faculty members also, there is, I mean, one another proposal which I like, TARE, TARE. I mean TARE, but we call TARE, right? Some people tell TARE or TARE, TARE. You must have seen SCRB. And recently, just few days back, in the engineering category, almost we have recommended at around 20 or 25 proposals out of nearly 100 in computer science, electrical, electronics category. So here I would like to tell you, in whatever the core research grant or Supra or special research grant, any grant you will talk about in India.
Sorry to interrupt, sir.
Yes.
Sorry to interrupt. Actually, if you see the other departments, they have that equipments which can be included, sir. But if you see the most challenge what we find in the CSC, computer related projects, we are not, they are not, sometimes they are telling very clearly not funded for laptops, not funded for systems like, and most of the software also are open source we are having.
Right.
So
Right.
this is also one of the challenge which I found as a head of department when many people, were applying, sir.
Yeah,
I would
I'm
like
coming
to,
to the point.
sorry, this also I want you to address, sir.
Yeah. I'll address all this point. I know these are all important points. See, the first thing is when you submit a proposal, definitely your proposal has to be very good. Even I can show you one of my proposal. When I submit, right? Also, I analyze all this thing. Let's say when I submit or when I try to review, how I review. And truly speaking, I try not. Okay, personally, I don't try to take much proposal from Government of India. I try to take from the international bodies because I need flexibility in the research, right? And in that way, you can do good research. But still, I also have many government-funded projects, and even the success rate of my getting projects is around 99%. I have hardly, maybe, one proposal got rejected, but if I have submitted 15 proposals until now, my 14 proposals are accepted. Maybe one is rejected until now. So based on all this understanding, and also as a expert member, how I review the proposals, what I see. So money is not a problem. So when we try to look at the proposal, we don't look at the money, how much budget you have quoted, right? When we see the money, that will come. What we see first? First, we try to see, okay, what you propose something and you must have written some objectives. What is the objective of your research? We try to see in the objective whether you have talked about some kind of novelty or the new things or not. Because the first mandate of Government of India, this experiment is that that whatever research you are undertaking, that should contribute to the knowledge of science. That should advance our knowledge, or it will translate to the technology development. So there are two kinds of research. One is fundamental research, another is technology development. But the present government, they are more interested in technology development. If you are bringing some product out of it, then they will be very, very happy, right? So, but in the same time also, they also encourage in different mode that to do fundamental research, right? So when, let's say you are proposing one subject, okay, this is the area, this is my project title, and this is my objectives. So first we see this objective and title. Then directly we'll go to your research record. Okay, whatever the idea you propose, whether you have done some kind of research in this area or not, right? And I'll go to your profile and I'll see, okay, I have done PhD from this or MTech from this and BTech from this, right? So as you know, let's say, okay, if I'll ask you, in your college, if somebody is applying, or let's say for your faculty position, one person has done BTech from any IIT, and another person has done BTech from some third grade college. I'm not taking maybe any college, there are many colleges in India, third grade college. To whom you will select? Definitely the student who is from IIT, right? Because you feel that, oh, he crack IIT JEE and studied from IIT, must be he is knowledgeous, right? So similarly, this kind of concept also applies. You see, we all are human beings. We see that from where this person has done BTech, MTech, or PhD. And the same time, we try to see when the person is doing the BTech or PhD, with whom he has done, whether he or she has acquired the right kind of training or not. Basically, we try to check whether this person is trained or a right kind of engineers or scientists or not, right? So if you are from a good place and we feel that, oh, he or she has received from a, let's say, Anna University, we know this is a good university, or maybe Madras University, or maybe IIT Madras, or IIT Bangalore, definitely people will feel that, oh, as the person is from a good institute, done PhD, definitely she or he must have good background. Then what they do? They go to your publication record. Okay. So please try to have one or two good publication. And please remember, don't try to write Scopus index, UGC recommended. These are all irritating word for the reviewer, right? Because those who review your proposals, they are all very big uh, people. People means they are good in research, and mostly they are from ISC or IIT or different top-notch university in India, right? And they know which is good, which is not good. So you need not to write Scopus index. So that means, I mean, when you're writing Scopus index, you are telling this journal is best. No, everybody knows in their domain which are the best journal, right? So my advice would be, let's say somebody has 10 journal publication in Scopus index or UGC recommended journal, but let's say one person has only published one IEEE transaction. I will not consider that 20 or 30 paper. Even I might select this IEEE transaction paper, because I know that to publish in a IEEE transaction or any other top-notch journal, it needs the at least good amount of work, right? So this is how we check the person's ability. So sometimes what happens, the person or the group, let's say somebody has written that I want to apply or I want to work on the glaucoma or diabetic retinopathy, मान के चलिए diabetic retinopathy, and in their group there is no doctor, only the engineers are there. Then nobody will select your proposal, because they will feel that how come they can do this work when there is no person from healthcare side. And it's not about randomly taking people. You need to take the people, you need to select the people based on their expertise. Because sometimes what we do, we write a proposal, we feel, oh, this person is in IIT, let's put his name. We know him, but his background is not what you are proposing here. Then definitely, even if the big person's name is there in a proposal, but you will not get funded, right? So that's why, please remember, whatever you are writing, you should have the right kind of background in the domain or in your team's domain. Let's say, if I'm going to work on I will give one example. How? So you remember, first we see the title of your research, then we read what is your objective, what you are going to do, and what would be your outcome. And then, instead of reading the whole proposal, this is what I do mostly. I generally go to your background, from where you have done your degree, right? And with whom you have done your degree, whether your training is proper or not. So whether you learn the concept or you know the concept or not. Then what I'll do, I'll go to your profile to check your publication record. Key, the domain where you have proposed, related to the domain, not maybe exactly related to the domain, whether you have right kind of knowledge or not. And that will be based on your publication record. That will tell me, oh, this person has done this kind of work, already published. That means he has or she has knowledge, right? And if this is, I found that, oh, yes, this person has right kind of background and training in this area, then I'll go to your details proposal. I'll go to your methods, your techniques. And sometimes what happens, many people, they don't tell their techniques, that how they're going to do. So see, sometimes that's true that we should not tell everything what we're going to do, but at least we should tell something in kind of a logical manner. This is what I'm going to uh, do in my project, or this is how I'm going to take the steps so that I'll get this kind of outcome, right? And based on that, we first recommend. First comes whether we'll recommend this proposal for the funding or not. So once we see that yes, this proposal looks good and the person is very good background, then we recommend the proposal, right? Then the stage comes the budget. Budget, actually nobody sees your budget initially. Then they will come to the budget and they will see, in order to answer this question, whatever the things required, right? Let's say you are going to work on a AI kind of algorithm or data science. Then definitely I know for the data science, you need a computer, good computer, you need maybe data server, that I know. So then I'll see how many computers you have asked. So I know for this problem, let's say you need 2 computers, maybe 4 lakhs each, maybe 8 lakhs for computer, 2 lakhs for maybe some kind of data storage unit, maybe 10 lakhs. Let's say if you propose, no, I need 50 lakhs, then definitely I'll cut down that budget. I'll tell, no, 10 lakhs is fine for this kind of equipment, right? And based on your research proposal, also we judge how many people need to answer this question, right? So this is what people see. So it's not about the budget. So always you try to write the budget which you feel is justified, because the way, I mean, the proposal, what you are proposing, everybody can understand. And they also know that how much money actually you need. Okay. But please don't feel that budget, I mean, due to the budget, my proposal got rejected. No, it's not like that. The proposal get rejected because for the first reason is when you don't have any kind of research background. So let's say if you have not done good research, nobody is going to see why people. The government's money is one kind of taxpayer money, right? And when the government will give you the money, they will at least feel that you are able to produce something, some good outcome. And if that kind of sense is not coming from your proposal, then they will not, definitely they will not give you a project. This is what happens, right? And that's why for all this young faculty, those who are attending my talk, please try to submit the TARE project, TARE. And if you get a chance, try to get involved yourself with some good researcher, good people, those who are working in your domain, and try to do some quality research. Please remember, one good paper is enough than 20 or 30 random papers. Try to publish one paper in IEEE, or try to publish IEEE or elsewhere, that standard journal, right? You need not to write Scopus or this UGC recommended journal. I hope you understood what I mean to say. So that's why TARE is a good program. Why? Because TARE, under TARE, you will get good amount of support. You will get 5 lakhs for every year, and also you will get I think 60,000 per annum, including your whatever you are getting the salary from your institute, right? And in that program, you have to find out one supervisor from any top-notch institute or IIT or NIT, those who are good in that domain, and you can work with them and then create your background. And once you have enough good paper, then you can go directly to this CRG or SRG or Supra kind of proposals. Okay. And this TARE, this power grant is very good for the women. Please apply. There are lots of funding. Even sometimes in many, we don't get the quality proposals. Truly speaking, funding is not a problem. Government tell, please select this much of proposal. But until unless you are not convinced it's a good proposal, how you can recommend? You cannot recommend. That's why my advice is, first you try to create your good background in the research area or the area where you are going to propose, right? Second thing, try to write a good proposal, right? And how you can write? So you can write the good proposal in that way. Whatever the problem you're taking, try to find out the lacuna in the problem, or what are the problem, or what are the questions are not being answered by anybody. This is the crux, right? Any questions you have, or I would like to show you one of my, let's say, my proposal. Hello, can you hear me?
Yes, sir. Yes, sir, we can hear you.
So any questions until now? Please ask me.
No, sir, it's fine. We can proceed.
Okay. So you are, I hope I answered all your questions related to the proposal, right?
Yes, sir.
Okay. Let me share one of my proposal maybe. So yeah, actually sometimes even many people also, even when I was just like you, when I was about to submit a proposal, also I used to think that how they select. But when I am also in the committee, I see, and the way I evaluate, now I can understand. Okay, so sometimes many people tell that how come all funding goes to IIT, why not we don't get the funding? It's very obvious. First thing, see, those who are in IIT, at least, I'm not telling everybody, but mostly they do good research, right? And they have all good publication record. And in that way, all the committee members feel that, oh, he has already good publication record or very good quality research. Definitely he can take forward this proposal. So just think, in your home, right? Let's say you have 10 siblings or 10 brothers and sisters. So you have seen, you must have also observed, your parent only will believe that who is doing right kind of job, right? They will assign them, okay, do this, do that, but not to every child. The similar kind of things happen here. But at the same time, please remember, as I told you, the just like the government of India is also many different kind of programs uh, to strengthen your research profile. That's why TARE proposal is one of them, and TARE actually that evaluation just finished just 3-4 days back. Okay, so mostly it will come again in February or March. And please, by the time, prepare your background well and talk to some professor in any IIT or any ISC or NIT to whom you feel that they are great in that domain, and then try to create your proposal, right? Let me share. Okay, let me find out one of my proposal. Okay, let me show you this proposal. Okay. Let's say this is one of the proposal I'm showing you.
Sir,
yes,
I have a few, I should not say as a question, some points which with concerns, I should say.
Yes, yes, please,
See,
please.
if IITs alone are given, so others are getting deprived, no, sir. So how do, as you said, is it required that the faculty members should associate in the initial publications with the IIT professors and IISc professors, and then approach for the funding? What is your suggestion, sir? Please do not
I told
mind
you.
my question. This is just for information of all, so that it will be helpful for them to come up with their own research and funding proposals.
Yeah, no, I told everyone that this is not mandatory. Let's say if myself, I can do good research, I need not to depend on others. Then already my profile is good. So what I'm telling, let's say if somebody will tell, ki until now we didn't get a chance to work in this good environment, or we don't have this facility, how come we can publish, right? That's why, in order to answer this question, this government has come up with this TARE proposal. So TARE means teaching assistantship something. I mean, you can see the full form. TARE, SERB. So in that proposal, you will get the grant. This is also a project, right? So you will get 5 lakhs every year for your research, and on top of that, you will also get some kind of salary. I mean, let's say you are a faculty member, you have to be a faculty member in any college, then only you can apply. And in that way also, you will be, I mean, and in this proposal, the mandate is you have to be connected with one professor in any IIT or any good institute where you feel that this person is good, I mean, or where I am interested to work. So working in that area or working with that group, at least you can publish some paper. So once you are done or you have created your background, then you can individually go and apply in big grants. This is what I said. Clear?
Yes, sir. Thank you, sir.
Okay.
Please do not mind, sir. This is just
No, no, no,
for,
no, no, no.
like
No,
for
no, no.
the
Even I'll be happy to
for
answer.
all the faculty members, because many are from the private universities. That's the reason I had to raise this question.
No,
Thank
I
you,
mean,
sir.
that's why I told you. Mostly, even I have seen many private university people, I mean, almost all, they apply this kind of, not only private, government also there, but mostly private. And this is the best way. Actually, see, so definitely, I mean, this I can imagine if you have not, I mean, right kind of laboratory or right kind of guidance, then how you can do good work? For sophisticated work, you need the right kind of tools, techniques, everything, right? So for that's why this proposal has come up. This is called TARE, where you will get a chance to go to different IIT and do your research and publish and make your profile better. Okay. So can you see my screen now? I'm showing you one of my proposal.
Yes, sir.
Okay. So I'm just okay. This is now under submission. I recently submitted this proposal in one grant. Okay. So I'm just showing how I've written that. Let's say this is the title. Some brainwave related things for welfare and warfare application. Then what I did, see my team members. So in this proposal, okay, just let's go to this objective. I wrote that what I'm going to do, and then I have my methods, and then I have written outcome, right? Whatever the outcome, how this project is going to contribute in the domain of science, and how the science will translate for the technology development, right? I've written here. Then I've written what are the risks in this project. Let's say if I have proposed something, I don't know that what I'm going to get, but what are the risks? I've written this proposal is very futuristic or ambitious kind of project, and this is what are the risks are available. But at the same time, if I can accomplish this project, I will get this kind of output. Then I mentioned about the novelty. What is the novel concept of my project? So then I said that throughout the world, those who are working in this domain, they have not answered this question. And this is what I'm proposing here. And if I can answer this question, it will be helpful for this and that, right? And when you are telling all this thing, you have to give with justification. If somebody has not done, have you done any review? If you have done, then you have to give the reference, right? And then I've written what impact would it make to scientific community or society? Then I've written what are the impacts of my projects, right? So likewise, let's say I've written, then this is the complete proposal. So this proposal is a very big proposal. You have to explain everything, the technology, everything, right? Then they will see that who are the team members in this proposal. I need somebody who is working on the animal. Animal means those who are working who can record the animal's brain signal. The person who understand the human brain as well as the technology, as well as the person from the communication background. Actually, this is what I'm trying to do. I want to control the brain waves, right? So for that, I need somebody from the communication background who has good understanding of the communication engineering, in the same time who can develop the technology for that. So that's why I selected people. I am the PI. Let's say I am the PI in this proposal, and he is another professor from our IIT. He is very good in communication engineering. Then I selected another scientist from another international research center who work on the genomics, and then two other professor from AIMS, right? And then somebody will see, okay, maybe this is a balanced team, and they will directly go to our profile, right? If they will go to our profile, so let's say this is around 4 crore project I ask, right? And here I have to justify the budget. Why I need this amount of money. So I've written where I want to spend this money. I've written everything, all this thing. Okay. Then here they will ask that what are the, okay, my background related questions, right? Whether I have good background in understanding the brain or not. Then they will go through my profile and they will see, okay, I have the publication in IEEE transactions, I have publication in Nature, I have publication in PNS, all the top-notch journals. And then automatically, I'm not telling myself because I'm showing my profile, but anybody will see, they will be convinced that I have enough knowledge in this domain. Then they will go to my other co-investigator. So the other and then they will see whether I have done any other big projects or not. Then they will see, yes, this guy has already done many big projects. Then he has enough background to handle this project. Okay. So then they will go to other people's profile, right? Other people profile is, okay, this is my biodata, my all this thing, my publication. Okay. Then another people. So here, then another guy will come. Unka bhi, people, they go through this domain. Let's say those who is working on the genomics, they will find, oh, this guy is also having very good publication. Okay. And then all these people, you will see here, okay, these are all publication record of all these people to whom I included. You can see here, the communication guy, he has hundreds of paper of IEEE transactions, right? So going through all this profile, definitely anybody will be convinced that this is a very well-balanced team and all these people have the right kind of expertise to execute this project. And all the people involved in this project have already done many big projects in India as well as outside, right? And then definitely this would be, one kind of all positive kind of things will develop in somebody's brain. Okay, let's fund this project. They might see my budget, then they will go to my budget. Whether they can cut down some budget or this budget, what I proposed, this is absolutely logical or not. Okay. So based on that, they take the decision. Okay. So I hope you got the idea. Okay. Then, after seeing all these things, then they will go through my details. Whatever I propose, how I'm going to execute this thing, whether I have explained clearly or not. If you will not explain clearly, then they will feel that you are just written some hypothetical things. There is no evidence exists, right? So accordingly, you have to fill your proposal and you have to write and then you have to submit. I hope you got the idea. Hello?
Yes, sir. Yes, sir. We can understand.
So please write in that way, and then I am telling you, nobody will reject your proposal. And again, I'm telling you, there are huge fundings. In government, there are lots of money, but there is no taker. No taker means, yes, many people apply, but if the proposal is not good, who will give you the funding? If the people, those who are in the committee, let's say 20 expert members are there, if they are not convinced that if will give money to this person, he cannot do this work, then do you think that they will give money? They will not give money. This is the problem. Okay. So that's the reason, as I told you, that's the reason all of my proposals get shortlisted or maybe selected or I get funding because I always choose the right team. Best, I mean, whatever I'm going to do, accordingly, I feel that who are the right kind of people. Mostly what happens when we write the proposal, what we do, I'm writing the proposal, one of my colleague will come, hey, please put my name. And somebody will come, please put my name. And we do many times like this. Don't do like this. You have to select the right team. And if you have the right team and they have good outstanding scientific record or the research record, then it will help you to get the proposal. And this is the way. Once I'm telling you, once you will get the proposal, then the things would be very, very slow. I mean, very, very simple to get the other fundings. Because once you can prove yourself that yes, I'm a good researcher, then when people will see your name, automatically they will not think much about you. They will tell, oh, he's a good researcher. Let's give him money to do the research. Clear?
Yes, sir.
Yes. Yeah. If you have any questions, I'd be happy to answer your questions.
Participants, you can ask a question if you have. You can unmute yourself and you can ask.
Yes, Tapan sir, good afternoon.
Yes, good afternoon.
Sir, I have one query. Like, suppose, is there any consideration of university ranking like NAC accreditation or NIRF ranking while we submitting?
Yeah, it bears a very less weightage, right? First, we don't care about from which institute this proposal belongs. We first see whether something is there or not, whether some good, um, uh, he proposed some kind of out of the box kind of idea or not. All these things we try to see, right?
Okay.
So
Okay.
the university does not bear any kind of relevance.
The second question is related to the publication. Suppose if we have the essay publication, I mean, in a journal, in a good reputed journal, then the weightage, what is would be the role of weightage in that case, in
What
as
is this?
comparing to transactions?
So I told you, na. So basically, if you are publishing any good reputed journal, that will give the sense to the reviewer that he has already good background. Because he has published in already good journal, that means he can do good research.
Okay. Thank you, sir.
Right? Let's say, in the communication engineering, let's say if you are working in the communication engineering, you know which are the best journal. If you are working on AI, you know which are the best journal. So the way everybody knows this thing, right? And this is how they will evaluate. There is no way just to evaluate. See, basically, वो ये देखना चाहते हैं, they want to see whether you are capable to do the proposed research or not.
Okay, sir. Thank you, sir.
Okay, welcome.
Any others whoever? Yes, sir.
Okay.
Participants, you can unmute yourself, speak and mute yourself. If you have any clarifications, please do ask. Participants, all of you can I think no more questions, I believe, sir. I think they
Yes,
are
I think so.
convinced. I request all the participants to switch on your camera, like, turn on your camera so that, we can take one screenshot with sir.
Yeah, excuse me, I have a query.
Please proceed, sir. You can ask.
Yeah. Actually, sir, I saw that in your proposal, you have you are using some animals, mouse or guinea pig or whatsoever. Sir,
Right.
so whenever you are using some kind of life, that is animals or human beings,
Right.
there are some formalities that we have to fulfill before. At what stage those should be fulfilled, like ICMR or something
Okay,
like
ethical
that?
clearance. Ethical, you have to
Ethical
definitely,
clearance,
if
yes.
you have to take the ethical clearance. If anything related to the human data or animal data, if anything is involved, you have to take the ethical clearance. Otherwise, funding agency will not release the money. Even you cannot publish your paper, right? So mostly the research proposal which I have submitted, if it will be approved, then I have to take the permission, because unless it will be approved, I mean, before get the approval, I cannot take the permission, because the ethical committee will ask me that from where you will get money for this kind of research. So that's why I just submitted, and if it will be approved, then I'll take the permission from the ethical committee. In IIT, we have our own ethical committee. So likewise, in many institutes, they have their own. But if you don't have your own, you have to collaborate with some people, those who have the ethical committee. Because without ethical committee, the ministry also will not give funding if you have this kind of animal or human related research.
Okay, right. Thank you, sir. So only when after the it is getting granted or it is approved, then only we can go for the ethical committee or those
Right.
things. Not before that. Not before that.
Before that. Yes. Not
Okay.
before that.
Okay. Thank you, sir. Thank you for being very specific regarding that. Thank
So
you.
this
Thank
is
you.
one thing. Another thing is that, let's say some people, what they do, let's say I have some idea and I want to realize that idea before submitting for the funding, right? So what I'll do, I'll take the ethical approval as a pilot study. So I'll propose that, okay, I want to do some pilot study. Please allow, I'll submit my all proposals, all terms and conditions, and I'll do that. So that is also another way. And that way also very good. So that way is very good in that sense, because you will prove your hypothesis and you have already some kind of ethical approval, and when you are going for the funding, that will make your proposal much more probable of getting the funding. Are you getting my point? One way, you can do your trial with some ethical approval, then submit to the funding agency for more money to carry forward your research, or you can submit the way I have submitted, and then if it will approve, then I'll take the approval.
Any other question? Any other questions, dear participants? Any questions, participants?
I can see 91 participants. So
yes, sir.
Yes.
Thank you very much, sir. It was really, mind-blowing session. What we could understand is actually like what are the different aspects that we really need to focus on to go for the funding, and the novelty, the importance of the novelty, and the different schemes. So it's really it was really interesting, sir, and it was really helpful for us. Thank you very much.
Thank you.
Thank you very much, sir. And it is really a great honor to have you with us, sir. And we will be having a valedictory function from 4 to 4:30. I will be really thankful if you can join the session for 15 minutes, sir.
Oh, actually, I have another meeting from 3 to 5, long meeting. So
okay.
maybe I won't be able to. But thank you very much for inviting me. Thank you.
Yeah, thank you. Thank you very much, sir. Thank you.
Okay.
So thank you, sir. Then I'll conclude this session. Participants, I have posted the day 5 session 18-19 feedback kindly fill in the feedback. You can, I think we have 20 minutes to rest also, like go have a quick lunch, and we will start the assessment from 3 o'clock to 4 o'clock. Okay, so it's something like, for all 5 days, I can understand if you see in Chennai and in Tamil Nadu, I think many places raining, and like I can understand the difficulty where many participants have represented it to me. So we are opening up all the links of day 1, day 2, day 3, day 4, and day 5. So if you have not attempted, like in the sense, you have attempted but you have not submitted, that's very important. If you have not submitted only, it will allow you to attempt that test. Okay, so you can open up and you can attempt the questions. See, attendance is mandatory. As I told you, you must have attended 60% of the sessions, but we ensure that all we are having all day attendance. Number 2 is the assessments. See, for certification, it's only the attendance that matters. For the assessment, like this is, we will just give the grade to know your status of your learning. Fine. So with this, is there any other question? I think have come to an end successfully. It's you people who made it very successful. Thank you very much. And we'll meet again after the session, like after your lunch session as well as your assessment session. So what I will do is now I will post the feedback, feedback is over, the assessment link in the chat as well as in the WhatsApp, okay? In the chat as well as in the WhatsApp. So whoever has not attempted, please make sure to attempt the assessment. Fine. Thank you very much. I'm closing. I'll just put the assessment link here in the chat as well as in the WhatsApp. I repeat. Okay. Thank you. Thank you all.
Hello. Madam, can we attempt now? Can
Sir,
we attempt the
actually,
assessment?
sir, for each individual, it is not possible to.
Okay,
answer.
understood. Thank you.
So
No
please
worries.
do not mind it.
Okay,
For all of
no
them
worries.
from 3 o'clock to 4 o'clock,
Okay,
we will keep it
okay, fine.
open. You can attempt it. Sir.
Yeah,
Thank you.
fine. Thank you. Thank you.
Yes, can couple of you unmute yourself and say it is not necessarily the positives. You can also say the negatives so that we can,
Madam, please. Madam, please.
Yes, sir, please.
Good evening to all of you. The coordinator, Dr. Anupriya Madam, the college, the organizing university, and all the participant faculty members. See, I'm a very beginner in this area and in this journey. Okay, and when I applied for this particular program, I wanted to have a particular pathway or roadmap on which I can start or I can work after completion of this workshop. And I think the workshop has fulfilled my requirements. I'm very much thankful to the coordinator, Dr. Anupriya Madam. All the speakers you had invited are very knowledgeable and very expert. All these sessions were very interesting. Practical sessions also were very interesting. The presentations made by them are very interesting. PPT files, program files, etc. And that's all. Thank you very much.
Thank you, Mr. Joshi. Express yourself. No other participants, then I think I can start with the vote of thanks. See, we started this FDP, like now this deep learning techniques for in the recent past. This has been one of the in the different fields of research. So that is the reason we started with this. And this whole program was initiated, with the intention of, support especially with language processing and deep learning. And I hope that that objective is satisfied. And we had totally 19 sessions, okay, and there were 11 resource persons, like renowned resource persons who were actually delivering the what is that sessions. So first, I would like to thank the KL management for giving us an opportunity, because when if there is an environment for us, to do the research as well as, I should really thank the KL University for giving us this opportunity to conduct such FDPs. Then I would like to thank principal, vice principal, and the all other faculty colleagues who were I would like to thank the resource persons, Dr. S. Margaret Annuncia, Professor and Director, Faculty and Staff Welfare, VIT University, Dr. Chunduri Sharada, Principal Scientist, ICAR Professor and Placement Coordinator, KL University, Hyderabad, Dr. J. Shiba Rani, Associate Professor, Avionics, Department of Space, Indian Institute of Space and Technology, Mr. Arun Chaudhary, CEO, Professor and Head of Department of Electronics and Communication, Sri Chitra Tirunal College of Engineering, Trivandrum, Dr. K. Ganesan, Senior Professor and Chair, VIT Business School, VIT University, Dr. Sunit Gupta, School of Engineering and Applied Sciences, Department of CSE, Bennett University, Noida. Dr. Teja Santosh, Associate Professor and Associate Dean R&D, KL University. Ms. Sukanya Mandal, she is the data scientist from the same Associate Professor, Department of Electrical Engineering, IIT Delhi. So I take special privilege in thanking all the resource persons. I thank all the participants, like for your patience listening. Yes, of course. Not shared, or like documents were not shared. These are quite common because this is an online FDP, and I created different channels, through which I can really communicate through mail, through WhatsApp, sometimes even through the text messages, through calls. It was I do understand, existing climatic conditions and, due to the work pressure and all these are there. Yes, I understand that also. That's the reason I have opened up the assessment link even at the end of the FDP session. I could see a participant from a wide range of colleges, universities. It is really very good to network with you all, and I will definitely be in touch with you. You can also always be in touch with me for future academic associations. Participating in this FDP, and I look forward for same kind of cooperation in the future FDPs also. And I would like to thank my team of organizers, Dr. KG Suma, who has been the seed for coming up with this proposal, and she supported me at every point of what is that step, to take the next step. Dr. Saidi Reddy, who has been taking care of all your feedback links, and taking these screenshots, and following up with the sessions, and for the media. So Dr. Saidi Reddy, I would like to thank Dr. Saidi Reddy. Dr. Shahjahan, who was responsible for all your assessments, collecting it from the resource person, compiling, creating the Google Forms, and of course that compilation work is also going on. Mr. Venk consolidate all your attendance from the WebEx, and he's giving me the overall attendance to me every day. So I thank all my organizing team members especially, and all the participants on the whole. Above FDP has given this, Atal Academy has given this opportunity. If that opportunity is not given, then obviously nothing would have been implemented. So on behalf of KL University and behalf of the faculty community, I really thank the AICTE Atal Academy for sponsoring such FDPs to enrich the faculty community and to support the student community. So this is my thanks to all the AICT officials who have supported us to this extent. Thank you very much. Thank you one and all. And I will share within 2 days, that is by Monday, you will get your attendance. You will also get the pending presentations, whatever is pending, those presentations, and the video links which you have requested for. We are planning to share, and tomorrow is Saturday, so maybe 1 or 2 days it will take. So mostly by Tuesday, I think Tuesday is 16th, I think 9th, no, 16th Tuesday. certificate part, I think after we post our attendance and what is that, assessments, of course, it will come directly to your registered emails. Please, because there were many confusions, like whoever has raised concerns about the links or about the presentations, the main problem was mismatch of the mail IDs in which they are joining in the WebEx and in which they have registered in the Atal FDP, like in the portal. So that was the main reason for this discrimination and like the problems. Of course, we tried our best to match. We will still there is room for improvement, so we will definitely improve it. Okay, so thank you all of you for participating once again, to one and all. Thank you very much. I close the FDP. I conclude the FDP and I close the FDP. Thank you very much. I'll end the meeting. I will end the meeting link. Thank you very much. Bye. Have a nice day and have a safe journey from now onwards, because the third wave, we are hearing that third wave have started and cases have started increasing. So stay safe and stay knowledgeable, and it is necessary for us to keep on learning as a faculty community. Let's all learn together. All the best. Thank you. Bye.
Thank you so much, Anupriya ma'am.
Thank you so much.
Thank you.
Thank you, Anupriya ma'am.
Thank you, ma'am. Thank you, sir. Thank you, Ms. Suja. Thank you, Mr. Raja. Thank you, Mr. Balamurugan. These are special thanks because they have posted in the chat, so I'm thanking them. Mr. Rahman, thank you. Ms. Archana, thank you. Okay. Thank you, one and all. I'm closing the session. Thank you.